Okay, I think I'm live now. We'll see how long it takes. See how long it takes. So I've clicked live, and obviously it's always this testing part of it, but I'm just gonna just check. Still not live by my computer. Right, chat. Okay. Still not saying I'm live. Okay, I'm live now. Add. Okay. Am I live? Am I live? Okay. Saying I'm live. Messaging. Just checking to see the chat. Let me just see. Am I live? Cool, cool. I haven't had Dan. Yes, Dan, we can see and hear you. Thanks a lot, Volatile. Cool. So we're here. Day before the final exam. How is everyone feeling for paper three? I know you guys are gonna cook that exam, but just let me know how you're feeling. But yeah, so what we're gonna do today is we're gonna go over both stats and mechanics. I'm gonna half it. Oliver, right, Dad, you need to save me on cooks for mechanics. Nah, bro, you got this. You defo got this. Oliver, you got this. But anyways, we're just gonna go over half. Stats, one half, and then mechanics the other half. I'm gonna try and do it uh in an hour and a half, right? So hopefully I can get through as many questions as possible. I've got quite a few to be fair. Yeah, let us have a go. Let's see how we get started. So I know what I need to do. I'm gonna go to scene for YT live stream, and then I'm gonna go here. So we're starting off with histograms and linear interpolation, right? So this is the question summarized here. I think it's about how many marks? Five. There's a lot of marks here. 7, 9, 10. There's 13 marks there altogether. So I thought we'd start off with this, right? So let's have a go. What I've done, I've actually summarized this question here. So have a read of it, the first part anyway, and then let me know what you guys think. Put a 0 if you think this is light. No, put a 10 if you think this is light, sorry. 10 if this is light, or 0 if I'm absolutely cooked. Let me know what you guys think. And let me what I'm gonna do, let me just go to another tab as well. Okay. And then what have I got here? Okay. Aaron, you're good. Aaron, you're good. You got this. You got this. Okay. So now let's have a look at this one. So let's have a read. It says a group of 100 adults recorded the amount of times, minutes they spent exercising each day. The results are summarized in the table below. So we've got the times here on the left, you've got the frequencies and the midpoints. And it says you may use the sum of f times x squared as that there. So that may come in handy later. A histogram is drawn to represent these data. The bar representing the time between 0 and 15 has a width of 0.5 and a height of 6 centimeters. Part A says we need to calculate the width and height of the bar representing the time of 60 to 120. So whenever I'm doing these types of questions, it comes up all the time. How much room do I have? Okay, I'm gonna do it here. So this is what we have here. Now I'm just gonna get that diagram again, with the frequencies and so on and so forth, right? So you're dealing with a histogram, and what I'm gonna do is I always just draw two rectangles just to represent what we've got now. So if I do the 0 to 15, right? So I'm going to draw a rectangle representing 0 to 15. It's going to be like, let me move this up a bit to be fair. Let me move this up and then I'll do it like this. It's going to be, hold on, let me straighten this up as well. Okay. So I'm going to draw a rectangle like this, and then this is going to represent, what is it? 0 to 15. Yeah, 0 to 15. This is the time in minutes. And we know that the width of this is 0.5 centimeters, like that. And the height of it is 6 centimeters. Now, what we also know is that we know the frequency of this. I remember the area always represents the frequency, right? So what I can say here is that the frequency is 25. So the area must be 25. And what I could also do is figure out what the corresponding area would be in terms of this rectangle. 6 times 0.5 is going to be 3, isn't it? So we can say that we've got 3 centimeters squared, right? And that has to equal the 25 units for the frequency. Yeah. The live is going to be about an hour and a half, right? It's about to be an hour and a half, probably around 9 o'clock. Yeah. So now, what I'm going to do is I'm going to draw another rectangle, and that's going to represent the bar that we're trying to calculate, right? Hold on, let me draw another one so it's a bit longer. Okay, perfect. And what do we know about this one? We know that this is between 60 and 120 minutes, right? Now, do we know anything about this? No, we don't. However, if I look at this here, the width of this from 0 to 15, right, is just 15. The width of this is 60 to 120. That is 60. So that must mean that the width has to be 4 times as wide, right? So if this is 0.5 centimeters, then this one is going to be 0.5 times 4, isn't it? Which is 2 centimeters. Does that make sense? Are we happy with that? Yeah. Cool. Cool. And I appreciate your comments, guys. I'm looking at your comments. I appreciate it. But yeah, so this is 2 centimeters, and then now, what else do we know about this rectangle that's between 60 and 120 minutes? We know that the frequency is 24, right? So I'm gonna write 24 here, right? Now, what we can do is have a look at this one, right? Because remember, what do we need? We need the dimensions of this. So what we can do is say, well, from this one, we know that 3 centimeters squared, right, represents a frequency of 25. So what we can do is figure out how much one frequency will represent in terms of centimeters squared. What would the area be for one frequency? And we're just going to divide this by 25. So let me just move this down a bit because I'm running out of room. I thought I had enough room. Let me move this down a bit here. So therefore, we're going to say then 3 over 25. If I divide both sides by 25 centimeters squared, that has to be 1 unit, right? And obviously, we can see here that the frequency is 24. So we could work out how many centimeters squared this rectangle is. Yeah? Mr. Ashby Master Dan boxing match. Nah, I'll lose. I'll lose. That's a goal right there. That's a goal right there. And yeah. So now we're gonna find out what 24 is because we want that frequency there. So I'm gonna times both sides by 24 to figure out the centimeter squared, the area of the rectangle that we're trying to figure out. So I'm gonna just put this here. It's gonna be 3 over 25 times by 4 times by 24, sorry, and that gives me 2.88, right? So 2.88 centimeters squared is represented by the frequency of 24. So I can write this here. 2.88 centimeters squared is represented by 24. And obviously we know that the width is 2 centimeters. So what would the height be? What times 2 gives you 2.88? That's just 1.44. Or you could just say h is just equal to 2.88 divided by 2. And that's just going to be 1.44. So the dimensions of the rectangle for a bar representing a time of 60 to 120 is just going to be 1.44 and 2 centimeters. I'll just put this here. 1.44 and 2 centimeters. And obviously that would mean, to be fair, that this is going to be a lot smaller. But yeah, you guys get the picture anyway. It doesn't really need to be accurate. But yeah, the maths is what's important. So I'll just do it like this. So it's a bit, so it's just contextually sound, basically. But yeah, we all happy with that? Where did I get 3 centimeters squared from? Ayla, I got that from this rectangle here. We knew the dimensions for the rectangle for the time between 0 and 15, right? They told us that the width was 0.5 and the height is 6 centimeters. So I found the area 6 times 0.5 to give me 3. Yeah? So, cool. Perfect. Perfect. And yeah, we're dividing by 2 because remember, I'm looking for the height of this rectangle. I knew the width was 2 centimeters and the area is 2.88. So 2.88 divided by 2 will give me the height. Tommy, hope that makes sense. Cool. So we've done that. Now part B. Let's have a look at this. It says use linear interpolation to estimate the median time spent exercising by these adults each day. Now, linear interpolation doesn't come up a lot, but it can come up, right? What I always do firstly is I always draw another column, and I'm going to call this the cumulative frequency. That just allows me to figure out how much of the frequencies are in each interval, right? So it's just easier to work out. So I'm just going to do this here, and I'm going to add all of these together now. So the first one's obviously going to be 25, 25 plus 17. Let me not make any chances and make any silly errors. So I'm going to do 25 plus 17. That gives me 42. And then obviously 42 plus 28 is going to be 70. And then 24 plus, that's 94 to be fair. I know that one. I can do that one, and this is 100. Yeah? All right. So we need to find an estimate for the median. Now, the median is the halfway point. We can see quite clearly that there's a frequency of 100. So the median is going to be 100 over 2, which is 50. So now I need to figure out what class interval does the median lie? And with the cumulative frequency, we can see that it's very, very easy. Yeah. So what does this all your luck thing mean? I see it all the time. Like I have no clue what that means. But anyways, yeah. So 50 is the median, and now I need to figure out where that lies. Obviously, it doesn't lie here. Too small. This is too small as well. It lies in the third class interval between 30 and 60. And essentially, what you need to do is figure out how far in this interval does the 50 lie. So what I always do is this now. I'm gonna say, I'm gonna draw another line like this. And I'm going to put this here, and I'm going to call this the time here for the interval. I'm going to call this the frequency. And if I look at this interval here, well, we can see that at the lower end, right, it's going to be between 70, isn't it? I put 70 here for the frequency, and it's going to go to 94, like that. Let me just double check. It's between, yeah, 70 and 94. And then now the time for this one is going to be 60, and it's going to be 120. Let me just make sure I've done that correctly. 25, 17 is 42. Yeah, cool. And let me just check the chat as well, just to make sure we're all okay with that. Perfect. Oops, I think I've got the wrong one. Sorry, that's 30 and 60. Sorry, my bad. I was looking too low. This should be 30 and 60. My bad. Should be 30 and 60. Like that. So we all happy with that? Does that make sense? And then we need to figure out how far this goes in. Yeah. So now let me just make sure chat is all okay. Okay. Is it sure? Okay. Okay. That 42 looking so too similar to a 92. Sorry. Yeah, sorry. My fours and nines, they're very, very similar. Apologies. But yeah, just let me know if I'm making any mistakes. Anyways, cool. So we need to figure out how far the median, right, is in this. Now we know that it's the median is 50, right? So I need to sorry, that needs to change, doesn't it? That's 30 to 60. That's 70 to 94. So what have I done? That's see 42 to 70. My bad, guys. It's gonna be here, isn't it? It's gonna be in here. So it should be 42 to 70. My bad. That should be 42 to 70. Should be 42 to 70. Sorry about that, guys. 42 to 70, 30 to 60, because obviously it's going to be in this one. So it's going to be 42 at the lower end, 70 for the upper end, and then 30 to 60 for the lower end, right? So now obviously 50 is going to be around here, isn't it? So I'm going to put 50 here. Now we need to figure out how far that is. And all you're doing is you're basically just figuring out the fraction of how far you go into this interval. So I always do it like this, like that. So what I need to do is figure out how far in this 50 is into this interval, and that is going to give me a corresponding value of t, right? So what I'm going to do is figure out the fraction here, and that would be, well, 42, I'll just do it like this. It's going to be 50 take away 42, because this is how it does it in the mark scheme anyway. 50 take away 42 out of 70 take away 42. And then what is this equal to? This is just going to be equal to, let me just check the chat. It's going to be, that's going to be an 8 here, and then obviously that's going to be 28, isn't it? And if I divide top and bottom by 4, right, it will be 2 over 7. So what that tells me is that this 50 is 2/7 into this interval here, which is going to be, the entire thing is going to be 28, isn't it? So I'll just show you here. The 50, right, is going to be 42, that's the start of it, plus 2 over 7, right, into this interval here, which is an entire interval of 42 to 70 is 28. So if I plug that into my calculator, that's going to give me 50. So let's do that and see what we get. 42 plus 2/7 over 28 times by 28. That gives me 50, right? So t then, just based on that logic, if I look underneath, well, the starting point is 30 plus that same fraction, because they have to be the same. And then what is the interval from 30 to 60? It's 30, isn't it? Like that. So therefore, this is going to give me the value of t. So I'll put that in and see what we get. Chat. 30 plus 2/7 over times by 30. That gives me 38.6, doesn't it? So that value there is going to be 38.6, and that is going to be the median time. Does that make sense? You happy with that? Yeah. So let me just see. So because I can see, don't know what he's answering. we're using linear interpolation to find the median time. So I'll just run through that very quickly. The median time is going to be 50 because it's 100 divided by 2. And obviously 50 was in this class here, 30 to 60, right? Because obviously 70 is less than that. 70 is more than 50. So we need to figure out how far 50 is into this class interval between 42 and 70. And obviously that corresponds to 30 and 60. So obviously we get the fraction here, which is going to be 2 over 7, right? So therefore we just use this formula here. So I hope that makes sense. Yeah. So checking chat, but he's just checking his working out that he did before the stream. You caught me, Leo. You caught me. You caught me. Okay, cool. So let's have a look now, and let's do find an estimate for the mean time, right? So part C, estimate for the mean time. What we can do is, well, there's a couple of things to do, to be fair. It's only 2 marks. I think you could just put this into your calculator, but I'll just show you what you can do just to get marks. The mark scheme doesn't have any calculations. I think you could just put your calculator, but obviously with this one, what you're going to do is you're going to just write a new column. This is just GCSE, isn't it? Midpoint times frequency. You're going to work out what all of these are, work out all of these are, and then just add them all together and divide by 100. So I'll just do that just to be on the safe side. So that one's going to be 25 times by 7.5, which is 187.5. And then 17 times 22.5, 22.5, that's 382.5. And then this is going to be 28 times 45, which is 1260. And then obviously 24 times 90, that's going to be 2160. And then the last one's going to be 6 times 180, and that's going to be 1080, like that. So you're going to add all of these together and then divide by the frequency, which is 100. That will give you an estimate for the mean, right? So why does that need to do it on the screen? Okay, let me just see. Who's spamming the chat? Okay, yeah. Let me. What do I do? Um, put user in timeout. How long can I put him in for? I'm trying to put him in timeout, but it's not letting me. Hold on. Okay, I'll put him in for 10 minutes. Confirm. All right. So he's been banned for 10 minutes. So hopefully that should be okay now. All right, cool. So hold on. Let me just. All right, cool. So now to get the mean, obviously we're gonna add all of these together. So it's gonna be 187.5 plus 382.5, 382.5 plus 1260 plus 2160 plus 1080, and that gives me 5070, right? So that's the sum. Obviously, the mean, which you can call x hat, is the sum of all of the frequencies divided, um, sum of all of the frequencies times the midpoint, sorry, divided by n. The sum of all the frequencies is frequency times the midpoint is 5070. N is 100 because the frequency is 100. This is just 50.7. So that's how you could do it, just to get marks and just to be safe, right? So what we can do as well, just because I think you can use your calculator. I'll just show you how you do it on your calculator as well. Let me just put this here. Where's my calculator? Yeah, I need to go here, and then I'm gonna go to 6 statistics, and I'm gonna go to one variable, and then I could just plug this in here. So if I plug all of these in, what do I know? X is gonna be the 7.5, 22.5, 22.5, 45, 90, 180, right? And then the frequencies, let me just double check I've got that correct. Yeah, that's all good. So frequencies now are going to be 25 for that one, 17 for that one, 28, and then 24, and then 6. And then now if I press option and I go to one variable calc 3, can you see that x hat there? That's 50.7, which is what we got, right? So you can do it like that. And I think this is what you need to do. Yeah. Yeah, I'm gonna do moments. I'm gonna do moments. Yeah. So now that is part C, and then part D. What was part D? Did I have part D? They didn't ask me for the division. Let me just check it here. Give me a sec. I think I missed the part. Where is it? Part D, calculate estimate for the standard deviation of these times. So let me grab that there. Let me just grab that. Put this here. Okay. So calculate the standard deviation now. I'll do this here. Let me just put this here. All right. Cool. So now from this calculation, right, we can actually see that the standard deviation is going to be sigma x, right, which is 44.5, right? So we could just do it here from there. But remember, 44.5. Let me just double check. Yeah, that's fine. And remember, the formula, which is going to be equal to the square root, and I always remember it as the square of the means. So it's going to be fx all squared over n minus the mean of the square, sorry, minus the square of the mean, like that. This is the formula here. So if I plug that in to see what we get, that will just be, that is given to us 455,512.5 over 100 minus the mean, which is 50.7. And then I forgot to put a square here, by the way. Sorry. That should be 50.7 all squared. That's the formula. So now if I plug that in, that should give us the same thing that we got. So let me just go to menu. How do I go back? I need to go here and then calculation. I plug in that in. That's going to give me 455,512.5 over 100 minus 50.7 all squared. I've been on this question for ages. And then that's going to give me 44.5. So you get the same thing, yeah? Just so it's all clear, 44.5. Cool. So let me just say, are you allowed to use that calculator to get answers? Do you have to show all working? So I think you have to show working, right? So what I would do is I would just show my working, yeah? Just to be on the same. You could always just use the calculator to verify what you've got so you know it's correct, yeah? So let us have a go now. Part E says describe, given a reason, the skewness of the data. Now, whenever they ask you to describe the skewness of the data, right, you're just comparing the median and the mean, right? So remember the median was 50, right? And the mean, let me just double check what my answers were. So the mean was the mean time, right, was 38.6, and the mean is 50.7 here. So let me just check again. Okay, cool. Good stuff. Yeah, so you're just comparing the median and the mean, right? So we figured out an estimate for the mean of 50.7 and the median was 38.6. Yeah. So the median, by the way, is 38.6 and the mean, right? What we just calculated is 50.7. Yeah. So if the mean is greater than the median, which it is in this case, right? Mean is greater than the median, right? Which is going to be 50.7 is greater than 38.6. It means that you have a positive skew. So basically your distribution is going to basically go like this. Let's just say your median is here, and your mean is here, which is larger. Yeah. So therefore you're just going to say it's got a positive skew. Positive skew. Positive skew. Whoops, write this better. Perfect. Cool. That's it. And then the last one, the last part of this question says further analysis of the above data revealed that 18 of the 25 adults in the 0 to 15 group for the time took no exercise each day. State, given a reason, what effect, if any, this new information would have on your answers to. First one is asking us about the median, the estimate for the median, right? Now remember, the median is the middle value, right? So let's get our table again just to contextualize it, right? Okay. So the median is the middle value, right, of this data. Now, the values, what was the median, by the way? The median, let me just get the median. The median was it not 38.6, right? The median was 38.6, right? Now, for the times between 0 and 15, that's less than that. So because the values have changed to the left of the median and nothing's changed greater than the median will stay the same. Yeah, so this is going to stay the same. That's going to stay the same. We hope that makes sense. When do the hard questions start? Okay, cool. I'm gonna get some hard questions. Don't worry. I've got some mad questions as well. Yeah, this is an Edexcel, by the way. Cool. Now, can you get the marks if you say the median does not equal mean? Katie, you'd have to specify what is greater because it's asking you about the skew. Yeah. So don't worry. We're gonna get some hard questions now. The estimate for the mean. Well, if these values are now zeros, right? Well, how many of them? They said 18 of them are zeros, right? That means that we're going to be summing 18 zeros. The mean is the sum of all of the values divided by the amount. If I'm summing with zeros now, it's going to naturally get smaller. It's going to naturally get smaller. right? That's going to get smaller. And then the last one, the estimate of the standard deviation in part D. So remember, the standard deviation is the spread of your data, right? Now, essentially, what we're saying here is that we're using these values 7.5s, 22.5, 45, 90, 180. So you can kind of think of it as being spread from 7.5, 22.5, 22.5, all the way to 90 and then 80, 90 and then 180. Now, if we've got zeros in the picture now, because remember they said that 18 of these are zeros, it means that the data's going to be more spread out, isn't it? It'll be more spread. So therefore, this is going to get larger. Yeah, it's going to get larger as there's going to be more spread. Cool. And that's that. So now, yeah, it's a pretty easy topic, but I thought it would be helpful to go through because it could be just a question one, right? And linear interpolation hasn't really come up from what I can see in the last couple of exams. So yeah, can you repeat part F? So let me just run through that very quickly because time is actually going. Estimate for the median is going to stay the same because obviously the median is the middle value. The values that are zero are going to be to the left of it, so it's not going to affect the middle value. The mean is going to change because you're summing values of zero now, and then the estimate for the standard deviation will get larger because the data is more spread out because you're including zero. But you can always just watch this back as well. So let's get some harder questions now because apparently that is too easy, right? So I've got this one. This is a mad ass question, right? So, a lot of you did ask for mad ass questions. So I think part A is easy, right? But part B is a bit tricky. Yeah. So let me just see what we think about this one, right? So I'm just gonna give you a chance to have a read of it, and then let me know what your thoughts are on binomial distribution. Time is going quick. I might have to go to mechanics soon, to be fair. But yeah, cool. So let's have a look now. Let me just see. All right. So says the probability that a student answers correctly the first question of a multiple choice exam is 0.2. A random sample of 30 students which sat this exam is considered. Part A says determine the probability that more than 5, but at most 10 students answered the first question correctly. So that's part A. That's not too bad. So I've got this summarized here. So quite clearly, we've got a sample of 30. It's a binomial distribution. So X is a binomial distribution. N is 30, right? And P is 0.2. And they've asked us for the probability that more than 5, but at most 10. So what does that mean? More than 5 is not including 5, so it has to be 6, like that. And then at most 10 is including 10. So to work this out, again, you've reached the time limit for YouTube.com. What's going on? What is going on? What are you talking about? Oh my days, ignore limit. Um, okay, hold on, I'm just looking at something on my Mac. How does this work? Oh my days, I don't know what's going on here. What is going on here? Let me just go back. Okay, cool. So now continuing, how do I calculate that? Well, that's just going to be equal to the probability of x being less than 10, right? And then we're going to take away the probability of x being less than or equal to 5. And that will give us the probability of x being between 6 and 10. So all I need to do is just punch this into my calculator. So this isn't too bad. This is easy, to be fair, but part B is a bit tricky. So I'll just do this here. Where's what I need? I need that there. I need binomial CD. It's gonna be 1. I'm gonna put 2 here. So I'm gonna put in 10. I'm gonna put in n as 30. I'm gonna put p as 0.2, and that's gonna be 0.9743 blah blah blah. 0.9743 8 blah blah blah. Right? And I'm gonna take away this one now. And if I go back to equals and I change that to a 5, I get that there. 0.4275 blah blah blah. And now I've got that number stored. So what I'm going to do is I'm just going to go to menu and go to calculation. That number's stored there. So I'm just going to do 0.97438. I can't remember what the other numbers, but this should be enough. That should be fine. That gives me 0.547. 0.547. So that's that. That's not too bad. Yeah. Well done, Alex. Good stuff. Picturesque. Well done. Medin. Well done. Yeah. Good stuff. Cool. So now part B. Part B. I want you guys to have a read of this and let me know what you think. Right. I'll give you a chance to read it. I'm just gonna just check my Mac because Yeah, by the way, because I'm using my brother's Mac, it just said the time limit has ended, or the time limit is up now. So I couldn't access YouTube, but it's back now, so I can see the chat. Anyways, cool. So let's read it. It says students earn 5 marks for answering the first question correctly, but lose 2 marks for answering incorrectly. Find the probability that the total number of marks scored by all 30 students in answering the first question is more than 17, right? When do you use continuity correction? That's when they ask you for a normal approximation. When they ask you for a normal approximation, that's when you use continuity corrections. So this one here, how do we go about doing this? Well, let's read it again. It says students earn 5 marks for answering the first question correctly and lose 2 marks for answering incorrectly. We need to figure out the total number of marks scored by all 30 students. And in the first question, this has to be more than 17. So what we're going to do is we're going to define a new random variable, right? We're going to say t, and this is going to be the total scores of all 30 students. 30 students, right? Now, there are students that are going to answer the first question correctly, and there are students that aren't going to answer the first question correctly. They're going to answer it incorrectly, and they're going to lose 2 marks. How can we express this though? Well, remember, what did we do in part A, right? This probability was the student correctly answering the first question. So what we could actually say is that x is our random variable, and this is just going to be a student answering the first question correctly. All right, first Q correctly, right? So we can call this x. I'm going to bring this down here because basically with this new random variable that we've labeled t, we need to write in terms of x. So now, if I want the total scores, remember, let's just say that the amount of students that get the first question correct, right, is going to be x, right? So I'm going to say t is going to equal the amount of students that answer the first question correctly is x, right? Now, if that's the case, how many students must answer incorrectly? Remember, there are 30 students in total. So that means that the students that answer incorrectly are going to be 30 minus x, like that. Now, remember, t is representing the total scores. X amount of students answered correctly, they get 5 marks, right? So I'm going to times this by 5. And then we know that the students that answer incorrectly lose 2 marks. So I'm going to times this by a -2. So I get this here. Does this make sense, guys? This is super important. Are we happy with this? Does that make sense? We're going to wait for you guys to say that this is okay. Yeah, cool. So, yeah, I think this is okay, just from what I can see. All right. So, all right, cool. That's fine. So now, what I can say is I can just tidy this up a bit. This is going to give me 5x, and then that's going to give me minus 60, and then that's going to give me a plus 2x, isn't it? Like that. So I get that there. And then uh re-explain please. Okay. So kind of confusing. All right, cool. I'm gonna do it again, right? So all right, so T, remember, is representing the total scores of all the 30 students, right? How many students are there? There are 30 in total. I know that the amount of students that answer correctly, I'm calling X, right? So if there are X students answering correctly, how many students must answer incorrectly? It's going to be 30, take away the amount of students that answer correctly. So that's going to be 30 minus X right here, right? So I'm just going to say there are X students that answered correctly the first question, correctly, and then 30 minus X will answer incorrectly. Incorrectly. Now, what would their total marks be? Any student that answers correctly gets 5 marks. So, for example, if there were 10 students that answered correctly, how many marks would they get altogether? They would get 10 times 5, right? So the total amount of marks that X students would get would be X times 5. X times by 5, right? Which is why I've got 5x there. And then obviously, the students that have 30 minus X are the students that answered incorrectly. They lose 2 marks, right? So if I lose 2 marks, I'm going to times by -2 because it's going to decrease. So this is going to be the total amount of marks for the students that have answered the first question incorrectly. So the sum of these two is going to be the total amount of marks together. Does that make sense now? Yeah? Okay, cool. So now we can say that t then is going to equal 7x minus 60, right? Now let's read the question one more time. It says find the probability that the total number of marks scored by all 30 students in this answer to the first question is more than 17. So what they're actually asking us for is the probability of t being greater than 17. But we know that t is in terms of x, and this is actually just the same as asking us for 7x minus 60 is greater than 17. That's what we need to calculate. And now this one is good because x was our random variable, right? For the first part, a student answering the first question correctly. So all we need to do is just work out what this inequality is and then use our original distribution. So if I do this, I'm going to have 7x and then I'm going to add 60 to give me 77, like that. And then now I'm going to divide by 7. That means I need the probability of x being greater than 11, right? Which is the same as probability of x being greater than or equal to 12, like that. So all I need to do, remember, this is in terms of x now, so we can use our original binomial distribution, where x was the random variable where student answers correctly. Remember, let's remind ourselves, n was 30, n was 30, and p was 0.2. So I'm going to put 30 here and 0.2. So I need you to work that out, and that's easy. That's going to be probability of x is greater than or equal to 12. That's going to equal 1 minus the probability of x being less than or equal to 11. So all I need to do is work that out and then take it away from 1. So I'm going to get my probability distribution. So I'm going to go to 7 and then binomial CD, which is what's that going to be? Binomial CD is here. 2 variable, I need 11 now, like that, and then I need n to be 30 and I need p to be 0.2. And that gives me that number right there. So it's going to be 1 minus 0.9905, blah, blah, blah. So therefore, I go back to calculation. That answer is always going to be stored. Answer equals stored. 1 minus answer. That's going to give me that number there, which is 0.0095, isn't it? 0.00, and I'll do it to 3 significant figures to be fair. 949. And that's it. Does that make sense? Yeah. How did you get 12? Because remember, it's probably of x being greater than 11 when I put it in terms of x, right? If I put it in terms of x, it could be x is greater than 11. Remember, this is a discrete discrete data, right? X is greater than 11 is going to be greater than or equal to 12, isn't it? So that's how I got that. Does that make sense? Yeah. Okay. Random variables as well, to be fair. So done that. How much time do I have? Got about 9 o'clock. I've got 2 discrete random variable. I've got normal distribution. Yeah, let's just see how it goes. We'll do this one. This one. This is another Madash question, by the way. So let's see how we get on with it, and then we'll go into the normal distribution. We'll go into pulleys and stuff. So yeah, what do we think of this one here? Put a 0 if you think I'm cooked. I have no clue, or put a 10 if this is very easy, very straightforward. Let me just see. Okay. Was there any connection? Was there any connection issues, guys? We just did this with Mr. Asprey. No way. No way. No way. No way. No way. No way. Whoa. It's a good question. It's a good question. So what even is this? I'm dead. You guys are killing me. You guys are killing me. Cool, cool. So let's have a look at it. Obviously, some of you may have seen it majority because I'm sure a lot of you were in his stream. But anyways, let's do it anyways. Question I've got. So it says the probability distribution of a discrete random variable is given by x. The probability of x is equal to r plus 1, and this is equal to 2 over 3 of the probability of x equals r, where r is equal to 1, 2, 3, 4, 5. And remember, there's a dot, dot, dot there, and it's 0 otherwise. And it's asking us to determine the probability of x being between 2 and 4, right? So how do we do this? This is very tricky, but remember, this is a discrete random variable. What you'd want to work out is the entire probability distribution. So what I'm going to do is I'm going to draw a table like this. I'm going to draw a table like that. And remember how this works. This is going to be our R, and it's going to be the probability of X equaling R, isn't it? Then I'll just draw some columns like this, like that, like that, like that, like that, like that. So we're here. Let me just check the chat if I've seen. Okay. So I'm just going to do it anyway because it's a question I picked out, and I know some of you may not have seen it. I'm sure a majority of you have, but I'm just going to do it anyway because it's a question I picked out right now. With this one here, let me just in the chat. Okay. So basically, we've got this here, and obviously this is going to be 1, it's going to be 2, it's going to be 3, 4, 5, 6, and 7, so on and so forth, right? And I'll do it a bit faster then if you guys have done this already. So now we need to work out what each of these probabilities are. Now, firstly, the probability of r equals 1, we don't know, but we can just call it a value, right? We can just call it k, yeah? Because it's just a number, it's obviously going to be between 0 and 1. Now, we know from this distribution here, thank you very much, Daniel Smith. Thank you very much for the £2. I really appreciate it. Much love, man. Thank you so much. But yeah, so doing this one, probability of r equals 1 is k. Now, we know that anything after that has a relationship with the probability before it. So what I would do is say, well, probability of x equaling r plus 1 here, right? We know is going to equal probability of 2 over 3 probability of x equaling r. So now, for example, if r is equal to 1, I'm just going to put r equals 1 here. If r is equal to 1, then what does that mean? That means that the probability of two-thirds, the probability of x equaling 1, right? Like that. That's going to equal the probability of x equaling. Remember, r is 1, that's going to be 1 plus 1. And that just tells you that the probability of x equaling 2 is going to be equal to two-thirds of the probability of x equaling 1. Like that. So now, we know that the probability of x equaling 1 from our table is k. So therefore, the next probability for the probability of x equals 2 is going to be two-thirds k. And then we can just continue in that same fashion. I'll just do another one just so you can see the pattern, right? And then now, the next one is going to be for 2. Now, I'm going to change this to a 2, right? That will be probability of x equaling 2 plus 1. So again, it's always good to just literally write it out so you can see the patterns, right? It's going to be 2 over 3 probability of x equaling 2. And we know that the probability of x equaling 2 is 2 over 3k. So I'm going to put this here. I'm going to put 2 over 3k like that. And that's going to be a 4 over 9k. And then obviously this is probability of x equaling 3, which is the next one, 4 over 9k. And by now, you should be able to see the pattern, right? What's happened is that we're doing k times by 2 over 3, right, to get there. We're doing 2 over 3 again. We're times it by 2 over 3 each time. So therefore, the next one's going to be 8 over, what's that? That's actually 27. 27k. And so on and so forth. This is going to be 16 over 81k, and so on and so forth. Does that make sense, guys? You happy? Yeah. And then 32, the next one obviously be 32 over 243k, and so on and so forth. Now, remember, this is a probability distribution. We know that all of these must sum to 1. So what we can do is figure out what k is, because what we can say then is that, let me just get the chat back up, because it just minimized. Okay. Yeah, yeah. You're gonna do sum to infinity. Yeah. So now you're gonna say that k plus 2 over 3k plus 4 over 9k plus 8 over 27, blah, blah, blah. Right, k. They all have a common factor of k. I can take that out, and that will give me 1 plus 2 over 3 plus 4 over 9 plus 8 over 27, and so on and so forth. And what you can see here is that you get a geometric series, don't you? Yeah, because the first term is going to be a, right? And by the way, this is going to equal 1, by the way, because it's the sum of all of the probabilities. This is going to equal 1. So the first term is going to be a. The common ratio, we can see we're timesing by 2 over 3 each time, right? So if I want the sum of all of these, this is going to infinity, right? So therefore, we could just use the sum to infinity formula. S infinity is going to equal 1, a over 1 minus r. So if I plug that in, that's going to give me 1 over 1 minus 2 over 3. That is 1 over 1 over 3. And that is just 3, right? So therefore, we can say that this here, I'll do it here. This one, k, this entire bracket is a 3. So we say k times 3 is equal to 1. So therefore, k is equal to 1 over 3. Does that make sense? Cool. Cool. Yeah. How did you know to use k? So Kermit, I just used k to just represent the value of a probability, right? Sometimes I actually saw in a mock set, they gave it to you as p, right? So k is just any value I've chosen, any value just to represent a probability for the first value. And then you could just develop the pattern there. You can use any value there. Yeah? Cool. So now we know that k is 3. and that would allow us to determine the probabilities for the ones that we need. So remember, they asked us to determine the probability of x being between 2 and 4. What that means, let me just screenshot that to be fair. Okay, so doing that one. Whoops, why is it not letting me screenshot? Give me a sec, guys. Let me do it one more time. Copy. Let me zoom out a bit and then paste it there. Okay, perfect. So I need to work out what that is. So probability of x being between 2 and 4 is going to be probability of x equaling 2 plus x equaling 3 plus x equaling 4, no? Like that. So that way, we could just look at our table, figure out what these are. Now, I'm going to write them all in terms of k, because it's just going to be easier than put k in after. So it's going to be, what's that? 2 over 3k. Let me just screen grab these to be fair. So copying these, this is for 2 to 4, right? Let me just check the chat. Okay. I think I'm going over. I think I'm gonna go over about maybe 5 or 6 questions. I didn't know it takes me quite a while to explain these, so I think I'll probably go over 5 or 6. I have 8, but I don't think I'll be able to go through all of them. But yeah. So doing that, probability of x equaling 2 is 2 over 3k. Probability of x equaling 3 is 4 over 9k. Probability of x equaling 4 is 8 over 27k. So now we can take out a k and then just work out what the fraction is inside. 2 over 3 plus 4 over 9 plus 8 over 27. And I think somebody, Narlin Fernando, thank you very much for the £5. Sorry, I did see it, but then I saw a question. So thank you very much for that. I really, really appreciate it. Thank you so much. Much love. And now we get this here. I'm a bit better today with the live chat. I'm looking at a lot more. You guys can agree with that. Yeah? So let's go now. Let's do the next one. Let me just this in. All right, cool. So now I'm gonna plug this in, and this is gonna be 2 over 3, 2 over 3 plus 4 over 9, plus 4 over 9, plus 8 over 27. And that will give me 38 over 27. So k times by 38 over 27. But remember, we know that k is equal to a third, isn't it? We found out k to be a third. So therefore, it's just going to be a third times by 38 over 27, which is equal to 38 over 81. And that's the probability of x being between 2 and 4. Does that make sense? Happy with that? Yeah? Okay. Cool. 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 Good stuff. All right. Oh, I think somebody sent me something. Oops. Leo, thank you very much for the donation. If we all donate £1, we can pay Boss for his time. I appreciate it, Leo. Zachariah, thank you so much for the £1. Really appreciate it. Zachariah. I think I pronounced that correctly, but thank you guys. Yeah. So this is this is probability distribution for anybody asking. So how much time have we got left? So I've done discrete random variable, guys. You guys let me know, by the way. I have a normal distribution question, right? But I also have pulleys, projectiles, moments, vectors, and kinematics. So I'm going to try and do 3 out of 4 of these. Should we go to mechanics now? Or should we continue with the normal distribution? I'm just going to see. Oh, I can make a poll, no? I can make a poll. Yeah. Hold on. Let me just see. How do I make a poll? Start a poll. Mechanics now. What should we do? I'm going to make a poll, guys. Give me a sec. Should we do? What should we do? Sorry, guys. I'm new to the streaming thing. What should we do? Um, Mechanics now. So now say it's taking long, or continue with stats. Continue with stats. All right. This is actually so cool. Now, if I start poll now, then now that should work. So let me see. Where's the poll? And thank you very much, AZ Studios. Thank you very much, Harry. Thank you very much, Mahi Deb. I really appreciate it. Will Gardner, thank you so much. Right? Now, let me just see. Where's the poll? Where's the poll? Guys, I don't know how this works. I did the poll. Oh, wait. I'm not doing because I'm zoomed in. Hold on, guys. Oh, it's at the top. Nah. I'm like an old man. I don't know how to use this at all. How do I go up then? All right. So it's 50-50. It's 50-50. It's 50-50, it's saying. So it seems like I'm gonna go through the normal distribution. Now it's continuous stats. Okay. Okay. I'll do the normal but quick. I'll do the normal but quick. Okay, cool. Cool. So base, okay, cool. I'm gonna do the normal. Now, let's have a read of it. So it says Jaya writes a computer program that randomly generates values from a normal distribution. He sets the mean as 40 and the standard deviation as 2.4. Part A says find the probability that a particular value generated by the computer program is less than 37. So this question isn't too bad anyway. It's not too long anyway. So where is it? Yeah, I've got this. I've already got it summarized there. So this is part A. Now, again, this is where's part A? Part A is right here. Perfect. So this one's pretty easy. We've got a normal distribution. The mean is 40 and the standard deviation is 2.4 squared. And they just ask us to find the probability that a particular value generated by the computer program is less than 37. So they just ask us the probability of x being less than 37. That's not too bad. That's a nice 3 marks, to be fair. This is from an international paper, so I think they're a bit generous with the markings. So I do this here, and the normal CD is going to be the lower bound. Let me move this here. The lower bound is going to be a really small number, so minus 10 to the 10. The upper bound is going to be just make sure upper bound is going to be 37. And the standard deviation is 2.4. The mean is 40. Plugging that in, that gives me 0.106 to 3 significant figures. And that's that. Does that make sense? And let me just have a look. I think I'm going to end the poll now. And then I think somebody sent me a donation. So I'm just going to just scroll up and just see. How do I do that? Thank you very much, Harry. Thank you very much, AZ Studios. I think probably Mahi Deb. I think I already said thank you to this, to be fair. Yeah, no, I did. But I think I can see a £5. Treat your missus with some flowers. If I had a missus, I would do. I would do. I appreciate it. I appreciate El Haji for the £5. Okay, cool. So you've done that. All right. So let us continue now. This wasn't too bad. Now part B. Now I want you guys to have a read of this one and then let me know what you think of it, right? So we'll read it together. It says Gia changes the mean to M but leaves the standard deviation as 2.4. The computer program then randomly generates two independent values from this normal distribution. The probability that both of these values are greater than 32 is 0.16. Find the value of M given your answer to 2 decimal places for 4 marks. What do we think of this one? Just see. Okay. You guys are killing me. You guys are killing me. You guys are so funny. But yeah. Can I could bro have no way. He's the reason. You guys are funny. Let's do some maps. Let's do some maps. Let me just zoom in a bit. Okay. So let's continue now with this one. So they're telling us that there's a new mean for M, right? So let's just go here. Distribution is going to be N, and the mean is now M, and the standard deviation is 2.4, right? So that means I'll put a square here, to be fair. Put a square there. Sorry. Let me just go back to the chat just so I can see. Okay, cool. And then let me go back to the chat. Let me just see the answer. All right, cool. So now, yeah, doing this, probability. It says the computer program randomly generates two independent values from this normal distribution. The probability that both of these values are greater than 32 is 0.16. Find the value of M. Now, what does that mean? We've got two independent values, right? And the probability that both of these values are greater than 32 is 0.16. So both of these values are greater than 32. So because there's two independent values, right? Can't we say that that means the probability of X greater than 32, whoops, greater than 32, and again, probability of X greater than 32, right? This is equal to 0.16. Isn't that what it means, right? So what we need to do is say, okay, well, fine. Remember, they're independent, so we can multiply them together. If I multiply them together like that, 32 times that, 32 equals to 0.16, right? We can just say, well, we could actually figure out what the value of one of them is because this is just squared, isn't it? Probably of X being greater than 32 all squared like that this is going to equal 0.16. Does that make sense? Just before we continue, we all happy with that? Yeah. Cool. So that way, we've actually can figure out the probability of a value here. And that's good because now we can just use a standardization to figure out what m is and so on and so forth. So now, probability of x being greater than 32 all squared is 0.16. Square it in both sides. That means the probability of x being greater than 32 is just equal to 0.4, right? Square root of 0.16 is 0.4. So now, what we need to do is, let me just see. Cool, cool. M equals 31.39. I think that is Charlie the man, from what I remember. I'm gonna just check. But anyways, we know the probability of a value being greater than 32. It's 0.4. So again, it's always good to visualize these questions, right? So got this here. I'm gonna draw normal distribution bell. Whoops, that's awful to be fair. Let me do it again. Give me a sec. Stroke eraser. Let me zoom out a bit. So get this here. Got a normal distribution bell. What we're saying is that, well, the mean is m here. We don't know it, but there's a probability of it being greater than 32, which is 0.4. And that kind of tells you, to be fair, that tells you that 32 is going to be to the right. So you actually know based on that, because this is going to be 0.4, isn't it? Which is going to be less than 0.5. So you know that whatever m is, it's going to be less than 32. So this is just another way to just see you're going in the right track. Yeah. So now, what do we do? Remember, we've got a normal distribution curve and we've got an area, right? We've got an area. We could use the inverse normal to figure out what the z value is by standardization, to be fair. So if I'm going to draw another one like this, like that. So remember, if I standardize, if I get the standard distribution for z, right, the mean is 0, the standard deviation is 1, there's going to be a value that corresponds to that same area of 0.4. What is that z value? Well, all you're going to do is standardize. So firstly, though, I need to figure out what that z value is, though, and I'm going to use the inverse normal to do that, aren't I? So if I do that, that will give me 7. I'm going to go to 7. I'm going to go to inverse norm, which is 3. And then I'm going to, remember, by the way, my calculator just gives me areas to the left of the value. So I'm going to have to put in 0.6 to get that z value. I hope that makes sense. Let me know if that doesn't make sense. I'm going to put in 0.6 instead of 0.4. Yeah? The mean is 0. Standard deviation is 1. Mean is 0. So I get this here. And this gives me this value here. So therefore, z is equal to 0.253 blah, blah, blah. Does that make sense, guys? Let me just make sure. All okay. Cool. So now we've got the Z value that corresponds to this value here, right? So what we can do is say, fine, because I've got that, we can now standardize. So remember the standardization formula, right? X hat, no, not X hat, sorry, just a value of X minus mu over sigma, right, is equal to Z, right? This is the standardization formula, isn't it? So what we can do is just plug in everything that we know, yeah? So the value that we know based on this is going to be 32, right? So it's going to be 32 here. That's the value that we know. Minus mu, and by the way, mu is m, isn't it? Because that's the mean. I'm going to write m instead. Over sigma, which is what was sigma against the deviation was for this one was 2.4, isn't it? Yeah. Over 2.4. This has to equal that value there. 0.253 blah blah blah. And then now we can just rearrange to figure out what m is. So let me just check. So now, if I just rearrange this, I've got that number stored there. So what I'm going to do, I'm going to just go back to calculation and it's stored. Yeah, perfect. So therefore, if I just rearrange this here, it's going to be 32 minus m is going to give me 2.4 times that number. Blah, blah, blah. And that means that m will equal, let's say, m is going to equal, if I move that there, there's going to be 32 minus that, isn't it? 22.4 and then 0.253, blah, blah, blah. So I'm going to put this into my calculator and that will give me m. So it's going to be 32, take away 2.4 times the answer. And that is 31.4, right? If I want it to 3 significant figures, 31.4. And that's m. Does that make sense? Well done, 310. Yeah. Why did you times the probability of x being 32 twice? Because remember, they told us that there are two independent values, right? The probability that both of these values are greater than 32 is 0.16. So we've got two values and they're both the probability of x being greater than 32. So probability of x being greater than 32 and another one, we times them together because they're independent, right? that make sense? Yeah. Okay. Cool. 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 So we've done this. So that's done. And then part C. C. So let's have a read of this one. It says GN now changes the mean to 4 and the standard deviation to 8. The computer program then randomly generates 5 independent values from this normal distribution. Find the probability that at least one of these values is negative. So what do we think about this one? This one's a little bit trickier, but it's not too bad. Let me know what you think. Put 0 if I'm cooked, I don't get this at all, or put 10 if this is easy. I'm just gonna go down. See? Okay. So there's a couple things to look out here for this one, right? Just go this here. Two. Okay. So, okay, you guys are fun. Anyways, so Jim now changes the mean to 4 and the standard deviation to 8. So X is going to be normally distributed now with a mean of 4, standard deviation of 8, so 8 squared. Says the computer program then randomly generates 5 independent values from this normal distribution. Find the probability that at least one of these values is negative. There's a couple of things going on here, right? Now, computer generates 5 independent values, right? So they're independent from one another, right? There are 5. That's a sample. They'll ask us to find probably that at least one of these is negative, right? So there's a couple of things going on here. This is a normal distribution question, but there's also a binomial distribution in disguise, right? So how can we see this? How can we visualize this? Well, firstly, the first hint is that it says 5 independent values. So I'm going to say n is equal to 5 here. Now it says find the probability that at least one of these values is negative, right? Well, how do we find the probability of a value being negative, right? We've got the normal distribution here. Remember, let's just get a bell curve like this, like that. The mean is 4, like that. And then if the value is negative, it has to be less than 0. So what they're asking us for essentially, right, is the probability of x being less than 0. That's what they're asking us for. That will give you a mark, right? Working that out. Now, with this one, probability of x being less than 0, we can work that out. Now, remember, once you figured out that probability, right, the computer has generated 5 independent values, right? So we can just say that this is just going to be a binomial distribution now with a sample size of 5, and the probability is going to be whatever this is, a probability of x being less than 0. Does that make sense? These questions come up quite a lot, yeah? It's a bit sneaky, but just let me know if that makes sense. I'm just checking. I'm going to just check. I'm doing this correctly. Yes, I am. Yeah, brilliant. So what we're going to do then is let's work out what that value is, by the way. Probably if being x less than 0 is going to be I'm going to go to 7. I'm going to go to binomial C. No, I'm going to go to normal CD, sorry. It's a normal distribution. The lower bound is going to be minus 10 to the 10, really big number like that. The upper bound is going to be 0, right? The standard deviation is going to be 8. The mean is 4. So I get this here. The probability of x being less than 0 is going to be 0.308. And all right, what's that? 5, 5, 3, 7, blah, blah, blah. That's the probability of x being less than 0. Yeah? Why is it less than 0? Because it says find the probability that at least one of these values is negative, right? Remember, G now changes the mean from 4 to 8. Probably computer randomly generates 5 independent values from this normal distribution. Find the probability that at least one of these values is negative. The probability of you getting a negative value in this normal distribution is the probability of x being less than 0. Yeah? Does that make sense? Cool. Mechanics is next, Hamza. Mechanics is next. Yeah? So now we've worked out the probability of x being less than 0, and there are 5 independent values. So what we're going to say now is that this is going to be now a binomial distribution. So hold on, let me just do. I'll just use y. It doesn't really matter, to be fair. But we're just going to say y is going to be another. It's going to be the binomial distribution now, and the sample size is going to be 5, and the probability is going to be this one here, like that, right? And it says find probably that at least one of these values is negative, right? So therefore, what we're going to do is we're just going to figure out the probability of y being greater than, at least greater than or equal to 1. Does that make sense? Happy that? Nah, no worries. I might have to overrun then. I might have to overrun. I didn't realize how long these questions are going to take me. But yeah. So now we're just going to do 1 minus the probability of y being greater than y being less than or equal to 0, right? Which is the same as 0 because that's the only one before it. So all we're going to do now is just work this out. And 7 distribution and then binomial, to be fair, it's just going to be PD or CD. Doesn't matter. I'll just use CD. Doesn't matter though. And variable 2, this is going to be 0. N is going to be 5. And P, if I put answer, I've got that answer stored, so it's really good. So now all I'm going to do is just plug this in and I get that number there. Yeah. So that number is 0.15 blah blah blah. So therefore it's going to be 1 minus 0.158 blah blah blah. And then that's going to give me 1 minus answer. So like that there. 1 minus answer, and that's going to give me 0.841. For let me just double check. 9 blah blah blah, that's 0.842. And that's the answer. Does that make sense, guys? Happy now? Yeah? Cool. Cool. Alright. Hamza Zar. I may overrun. Just let me know when you guys are gonna go to sleep, because I think it'll probably be like, if I do all of these mechanics questions here, probably be like another hour. Just based on how I explain things is how long it takes me. But yeah, just let me know. Just let me know. But yeah, Omar, you can just go back. What I'll do, if I've got time after, I will recap it. But because of time, I'm gonna just go to the next one. Yeah. So yeah, happy to go into pulleys now. So why did you change to binomial distribution? Because there was 5 independent variables. So this is, I'll just go back to that quickly. Um, because of the fact that there were 5 independent values. So this is a sneaky type of binomial distribution within a normal distribution question. Yeah, it's a weird question. Yeah. Anyways, so you do standard deviation over root n is when you're finding Mackenzie Cameron. That's when you're doing a hypothesis test for normal distribution and you've got a sample. That's for normal distribution. Yeah, for a hypothesis test anyway. Yeah. All right. Dan, I'm not sleeping tonight. Please do them all questions, please. Why is it 10 to the dead? Atlas, it's just a bit, it's just a small number. I wanted x is less than 0, so I need to make the number really, really small. It could be minus 10 trillion, whatever. Yeah, that's just what I did. Yeah? All right. Cool, 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 cool. I'll try and see if I can do a hinge question. Anyways, so let's have a look at this one here. It says that 2 particles A and B have mass 0.4 kg and 0.3 kg respectively. The particles are attached to the ends of light and extensible string. The string passes over a small smooth pulley which is fixed above a horizontal floor. Both particles are held with the string taut at a height of 1 meters above the floor, as shown in the diagram above. The particles are released from rest and the subsequent motion B does not reach the pulley. Find the tension in the string immediately after particles are released. Now this one here, I think part A and B is very, very standard, right? So I think I've got it summarized underneath here. Brilliant. So firstly, with these type of questions, remember, you've got to draw a force diagram, right? It's a 24-hour stream. I wish. But yeah, so find the tension in the string immediately. So first we need to draw a force diagram. And what did they say, by the way? What do we know about A? A and B, A is 0.4, B is 0.3. So A is heavier, right? So that means that this one is going to have a weight of 0.4 g. This one's going to have a weight of 0.3 g. Now remember, there's always going to be tension acting towards the pulley like that. Now, since A is heavier, it's going to go down. This is going to go down like this. Acceleration is going to be like that. And then this is going to go up like that. It's going to be A, right? So what you want to do, again, same type of question comes up all the time. You just need to do F equals ma to create 2 equations of motion and solve simultaneously. So if I do this for particle A, right? Now we know that it's going down, so the weight is going to be dominating and the tension is going to be resisting it, right? So it's going to be 0.4 g minus t is going to equal the mass of it, 0.4 a, right? Thank you very much, Luanvo, for the £2. I really appreciate it. Scotland are playing. Mate, I haven't even been watching the Euros. I don't even know who's playing or what. I'm gonna catch up after this. But yeah, so that's done. And then what do I have? For particle B, remember it's going up now. So it's gonna be the tension is gonna be dominating, and then it's gonna be minus 0.3 G. And that's gonna equal 0.3 A. Like that. So now we're trying to find out the tension, right? We've got a simultaneous equation. T is a variable and A is a variable, right? What you can do here, if this comes up tomorrow, guys, right? If this comes up tomorrow, what you can do is I've got equation one, I've got equation two. If you want to figure out what T is, right? You can just divide equation one and equation two like that. If I do this, I'm going to get 0.4g minus T. It's going to give me, on the numerator, it's going to be 0.4a here. And then divided by T minus 0.3g. And this is going to be divided by 0.3a. And then what happens here is that the a's are going to cancel, don't they? Yeah? So what will happen now is that that's going to cancel with that. And then now I can just cross multiply, right? So if I cross multiply, it's going to be 0.3 times by 0.4g minus t. And that's going to equal, that's fine. That's going to equal 0.3 times by, no, hold on. It's going to be 0.4, sorry. 0.4, 0.4, and then t minus 0.3g, like that. Let me just double check. 0.4, yeah, that's fine. Yeah, that's fine. And then now we've got all in terms of t now. And then now we can just expand and simplify. So what's that? That's 0. Let me just double check because I don't want to make any mistakes. 0.04. That's 0.12. Okay, I knew it. 0.12 g minus 0.3 t, like that. And this is going to equal 0.4 t, like that, minus 0.12 g again, like that. And then now what I can do is I'm going to add the 0.3 t. That will give me 0.7 t there. And if I add that one, that's going to give me 0.24 g. So therefore, the tension is just going to be 0.24 g divided by 0.7. And I'll put that in my calculator and see what I get. That's going to give me 0.24 times 9.8. That's g over 0.7. And this is 3.36. So the tension is 3.36 newtons. Does that make sense? Yeah? Okay. No, sir. Stop complicating it. Did I complicate it, guys? I took the long way. What did I do? Tension is the same, though. So we can plug them into each other. Yeah? Sorry if I complicated it. I thought this was a fast way, but you can do it however way you like, to be fair. You could rearrange and solve for one of them and equate them, to be fair. I thought this was quicker. But yeah, yeah. Whatever way you do it is absolutely up to you. Yeah? But yeah, so that's the tension. Now part B, which is what I've got underneath here. Oh, where's part B? I thought I grabbed it. I didn't grab it. Anyways, we need to find acceleration immediately after the particles are released. So that just means we need to figure out what A is now. Remember, we're solving a simultaneous equation. We know what T is. So we could just plug it into either one of these. And this will give us the answer. So where is it? I'll plug it into this one. It doesn't really matter. I'll use that one to get what A is. So that way, that's going to be T is 3.36, isn't it? Yeah, T is 3.36. So it's going to be 3.36 minus 0.3 g divided by 0.3. That will give us A, no? Let me just write T is equal to 3.36, so it's super clear what I've done. So now I'm just put that into the calculator and see what I get. So that's going to be, put this in there. 3.36 minus 0.3 times 9.8 divided by 0.3. Whoops. That gives me 1.4. So acceleration is 1.4 meters per second Yeah. Does that make sense, guys? Happy with that? Yeah. It's a splendid method, sir. I appreciate it, Officer Cucumber. I appreciate it. But yeah, well done, Alex. I got that as well. Yeah. 310, Abra, Nebulous Quartz. Yeah, 1.4. Good. All right, so that's done. Now, this is the harder part. So a couple of you guys did ask me for these types of questions, right? Whereby you've got connected particles, and then after they ask you about something that happens after it breaks or something like that, right? So it says when the particles have been moving for 0.5 seconds, the string breaks. Find the further time that elapses until B hits the floor. So with these types of questions, guys, let me know what you think of it, by the way. Put a 0 if you think I have no clue with this one, or put a 10 if this is easy. Goodbye, guys. Pray for my grade. Uh, See you later. Good luck for tomorrow. Hopefully you can watch this after as well when you wake up. But yeah, what do we think of this one? Makes sense? Difficult? Weird? What do we think? Okay. Right. So basically, what you want to do with this one now, again, let's just get our force diagram going. So what do we know? This is 0.4g. That's 0.3 G, like that. And obviously we've got the tensions like this. So basically you want to break these up into two phases, right? So phase one, I'm going to write this as phase one. Now, phase one is when the particles are connected. They've told us that when the particles have been moving for 0.5 seconds, the string breaks. We know that A is going down, right? And we know that B is going up, right? So what we need to do is figure out what's happened after 0.5 seconds. So essentially, I'll just do it like this. I'm going to draw a diagram like this. And then obviously, I'll just say the floor is like this, right? And then obviously, A is closer to the ground now, right? Like that, that's A. And now B is gone up a bit, like that, like that. And this is after, this is at 0.5 seconds. So T is equal to 0.5, huh? Let me just see the numbers. Okay, all good. So what we'd want to work out now is the distance. How far has this particle B traveled, right? We've got a couple of things to work out. How far has it traveled? Well, we're going to use Suvat. We know that the acceleration when it's connected is 1.4, right? What else do we know? The initial speed, it was from rest, right, is 0. And we're looking for S. What formula connects all of these four variables together is going to be S is equal to UT plus a half AT squared. So I'm going to figure out how far B has traveled in that 0.5 seconds just by plugging in everything in. Does that make sense, guys? We happy with that? Yeah. So I'm just going to do them and see what we get. So it's going to be S is going to equal 0 multiplied by T, which is 0.5. So that's going to go anyway, plus a half, and then A, which is 1.4. And then T squared is 0.5. So 0.5 squared. So I'm going to plug this in, and this is going to tell me how far the particle B has traveled in that 0.5 seconds when they're connected, right? So 0 times 0.5 plus a half, 1.4, and then 0.5 squared, like that. And that will give me 7 over 40. That will give me 0.175, right? So in phase one, we know that, remember, originally it was at 1 meters above. It's traveled 0.175. So we know basically then that this distance right here after the 0.5 seconds is now 1.175. That's how far it is above the ground, right? So now let me just see the chat. Okay, I'm not seeing anything. I've not missed anything, so the chat looks okay. So now continuing, right? What we want to figure out now is what is also the speed, right? Because remember, we're looking for the time, right? So we need a couple of things. We need to figure out how far it's going to travel back down. Remember, it says find the further time that elapses until B hits the floor. We know that at the time of 0.5 seconds, it's at a height of 1.175, right? So we're going to need that. So I'm just going to circle this. Now we want to work out how fast it was traveling the moment it breaks. Yeah, that's what we want to work out next. So I'm just going to write this here. I'm going to write speed after 0.5 seconds, right? What is that going to be? Well, that means we're going to look for V. We know the acceleration was 1.4. The time is 0.5. And the distance it's traveled, right? Or to be fair, we don't even need it to be fair, because we could just use V equals U plus AT, to be fair, right? So we could just say that U is equal to 0 because the initial velocity was 0. So we could just use V equals U plus AT to figure out what the speed is, right? So if I do this, then it's going to be V is going to equal U, which is 0, plus 1.4 times T, which is 0.5. And that is going to be equal to half of 1.4 is 0.7. So that is the speed that particle B is traveling the moment it breaks. Yeah, we're going to do moments. Don't worry, we're going to do moments. But yeah, so now what we want to do is say, well, in phase two then, because now we've figured out everything we need for phase one. So I'm going to write phase two, like that. And then we know that we've got this here. Let me just zoom out so you can see the diagram as well. So phase two, like that. And what do we know? Now it's broken, right? Let's just say it's like that. It's broken, like that. And then it was here, and then it's broken now. So let's just say it's like here. And then now it's going to travel downwards, isn't it? Let me just make this a bit bigger so it's clear. So like that. Now it's traveled downwards now. And we know that it needs to travel. How far does it need to travel downwards? It needs to travel 1.175 meters downwards, right? we know that the acceleration is going to be minus g now, right? Because remember, thank you very much, Ahmed, right? It's going to be minus g because the particles are no longer connected, right? It's just going to be moving through gravity. So I'm going to say A is going to equal minus g. And what else do we know? Let me just see. Just chat. Okay. And T is 0.566. I'm just looking at the answer now for anybody that's got an answer, right? So and by the way, to be fair, if A is minus G, that means I'm modeling upwards as positive, right? And so if I model upwards as positive, that would mean then that the displacement is going to be negative, isn't it? Minus 1.175, right? So I know that A equals minus G, right? And U, right, is going to be the speed that we know it was traveling at, which is going to be 0.7, yeah? And then we're looking for T. So we get that. Does that make sense? We happy with that? Just make sure all okay with that. Cool. So now we can just plug in everything that we know. So it's going to be, we're going to use, what formula we're going to use? S equals ut plus a half at squared to figure out what T is now. So now we're going to say, minus 1.15, minus 1.175, sorry, is going to equal ut, so 0.7 t, right? Plus a half, and then a is minus g, and then t squared, like that. So now we get minus 1.175 is going to equal 0.7 t minus 4.9 t squared, like that. And then now if I just move it from right to left, it's going to be 4.9 t squared minus 0.7 t minus 1.175 is going to equal 0. And then now you can just plug this into your calculator and see what you get. So I hope that makes sense. Let me just see the chat again, just so we're all good. How many people are here, by the way? I don't even know. I'm just going to check. 400 people. Wow, that's a lot of people. Okay, cool. So doing this now, yeah. Why did the acceleration go from 1.4 to g? Because Brit, in phase two, I forgot to put phase two, by the way, right? The string is broken now. Remember, the acceleration was 1.4 when the particles were connected. The particles are not connected now. So this particle B is going to move through gravity, right? So, yeah. B will rise before coming down. We already did that there. It rose to 1.175. That's what we did. So you could just go back for the person that asked that, yeah? So now, we're just going to plug this into our quadratic solver now and see what we get. So I'm going to put this here and then 7, what am I looking for? Calculation. Where is it? It's there. Equation func, polynomial 2, 4.9, like that, minus 0.7, like that, and then minus 1.175, 75, and I get these values here. So T is going to equal 0.566, or T is going to equal minus 0.423. And obviously t is time, so it can't be negative. So therefore, it's going to be the positive value. So that is going to be the time that elapses after, what was the question asking us for? Until B hits the floor. T equals 0.566. Does that make sense, guys? So with these types of questions, when it's slack, right, or when the string breaks, you just basically got to do it as two phases. Yeah? Cool. Cool. So now we've done that. Now, I was meant to end the stream at 9, but I can't leave you guys hangers without doing any projectiles or moments. So we're gonna have to get this done. Yeah. So let's just see how we get on then. I'll do projectiles now, and then I'll go into moments after. So projectiles, right? What do we think about projectiles, by the way? Put a 0 if you think I'm cooked if projectiles come up, or put a 10 if this is easy. Light work. Yeah. What do we think? Let's check the chat. Okay. Cool. Cool. All right. So 1,000. You guys are funny. You guys are funny. Now you're not skipping anything. You're not skipping anything. Okay. So let's have a read of this question and see how we get on with it. Yeah. So it says the points A and B lie 50 meters apart on horizontal ground. At time t equals 0, two small balls P and Q are projected in the vertical plane containing AB. Ball P is projected from A with a speed of 20 meters per second at 30 degrees to AB. Ball Q is projected from B with speed U meters per second at an angle theta to BA, as shown in figure 3. At time equals t equals 2 seconds, P and Q collide. Until they collide, the balls are modeled as particles moving freely under gravity. Part A says we need to find the velocity of P at the instant before it collides with Q. So I've got it summarized here. And remember, guys, there's always a table. I think I did this in the other live stream, but this is a table that you could use to just memorize your projectiles, right? Dan, get me out of the oven. Okay, the live will probably finish yellow hat at probably around 9:30, probably. Why has it gone blurry? Has it gone blurry? Oh, you guys trolling again. Hold on, let me just see. Looks fine to me. Okay, cool. I think you guys are trolling again. All right, cool. So, now it's the table, right, that tells you about the vertical and horizontal components of your speed, right? And as well as that, it gives you the distances as well. So the horizontal component of speed, and by the way, I should actually put this. This is when you're projecting a particle with a initial speed of u at an angle theta, right? So obviously your horizontal component is going to be u cos theta, and your vertical component there is going to be u sine theta, isn't it? Right? U sine theta. So this is just telling you the horizontal and vertical components of the speed. Yeah. So now, what we need to do is find the velocity at the instant before it collides with Q. So what we need to do with this one is we're dealing with P only, by the way, right? So what I would want to do is I've got to put particle P here, and I'm gonna figure out the velocities, right? The velocity at the times, right? So for example, it collides with Q after 2 seconds, right? So P and Q at t equals 2 after 2 seconds. So I'm just gonna write at t equals 2. What is the components of the speed of P? Now remember, the speed of P doesn't change. Now remember, if I've got this here and this is 20 and the angle's 30, right? Then the horizontal component of the speed, which we know doesn't change, is going to be 20 cosine 30. That's going to be so I'm writing theta. 20 cos 30, right? That's going to be the horizontal component of the speed, 20 cos 30. Yeah. Now, the vertical component of the speed, we've got to use that formulas here. Can we see? Right? I've got this one here, u sine theta minus 9.8t, which is just the same as v equals u plus at. I'm going to use that to figure out the vertical component of the speed after 2 seconds, right? So if that's the case, I'm going to say vertically now. I'm going to say vertically. We know it's after 2 seconds. Remember, the formula is going to be u sine theta minus 9.8t, isn't it? Right? That's just the C. Let me just double check. Yeah, perfect. That's going to be Vy. Now, what do we know about each of these then? Put this here. V is going to be, let me just check the chat. I asked the same question as live stream. No way. This is the second time somebody's done the same question I'm doing. Sorry about that. Sorry about that. But yeah, cool, cool. So continuing now. This is going to be V is going to equal 20. That's u sine 30 minus 9.8, and then t is 2, isn't it, after 2 seconds. So that's going to give me the vertical component, and I'm going to just work these out. So let me get my calculator. It's going to be 20 sine 30, like that, minus 9.8 times by 2. What does that give me? That gives me minus 9.6. So minus 9.6 is going to be the vertical component of the speed. And then this one, to be fair, 20 cos 30, which is the horizontal component. I can actually put that in my calculator as well, to be fair. 20 cos 30 is going to give me 10 root 3. So basically, what that tells us then is that the velocity of P after 2 seconds is basically like this. You kind of think of it as like a vector, right? It's going like that. This is 10 root 3. And the component going downwards is minus 9.6. Yeah. So if I want the actual velocity, I just need to find the magnitude of this. So I'm going to say V then is going to equal the magnitude of these two. So 10 root 3 all squared plus minus 9.6 all squared, like that. So I'm going to put this into my calculator and see what I get. It's going to be, whoops, I need square root, be 10 root 3 all squared, like that, plus minus 9.6 all squared. like that. And that gives me 19.8 to 1 decimal place. So 19.8 meters per second. And as well as that, the mark scheme actually asks you to figure out what the angle that it's at as well at this point. So if these are the components, right, then remember this is the actual vector here. It's traveling like that. The angle is going to be theta, right? So I need to work out what that angle is with the horizontal, right? So what I'm going to do is just use trigonometry. So I'm going to say theta then. We can see, obviously, there's a negative here, but if I just want that angle, I'm just going to do, theta is going to be the tan inverse, right, of opposite 9.6 over the adjacent, which is 10 root 3, like that. That will give me this angle there. So I'll put that in. Let's see what we get for it. So it's going to be tan inverse of 9.6 over 10 root 3. 10 root 3. And I get that 28.9 or just 29 degrees approximately. Yeah? 29 degrees. So to the horizontal. So yeah, that's what the mark scheme says anyway. Yeah, for the 6 marks, you need to figure out what the velocity is, 19.8 meters per second, and the angle that is traveling at as well. Yeah. Dan, you're kind of doing it a little bit confusing there. Sorry about that, KA. What part is confusing? I'm trying my best. Tan theta make. Okay. Nah, Mustafa, you're not flopping your A levels. Don't worry, you're not flopping your A levels. But yeah, just let me know what part is um confusing, right? And then yeah. Uh Yeah, so the mark scheme, so the question doesn't actually say the angle, right? The question doesn't actually say the angle, but the mark scheme says you have to put the angle in as well for anyone that was asking. Yeah. What about the minus 9.6? So yeah, the minus 9.6 just tells you that it's going downwards. Yeah. So obviously, if I put the minus 9.6 in, yeah, like that, that minus will just be the negative of that, and that just tells you that it's underneath. Does that make sense? Yeah. So cool, cool. Sorry, Mustafa. Sorry, Mustafa. Hannah, sorry, apologies. I'm trying. But yeah, hopefully if you watch this back, it should make a bit more sense. Yeah. Thank you very much, Ernest Dylan. And yeah, I'm not even on the market. That's a funny question. That's funny. But yeah, thank you for the donation. Yeah. But yeah, why did you find the modular V? Because it asked you for the velocity, right? So because we have the components right at that time t equals 2, then we needed to figure out the magnitude because we had the components, right? So okay, so all of it, please do a summary. So I'll just okay, so let me just do a summary very, very quickly, right? It says find the velocity of p at the instant before it collides with q, right? So t equals 2 seconds. That's when it collides with q. That's what they've told us, right? So what we need to do, if we want to find the velocity of p, we need to figure out the horizontal component of the speed and the vertical component of the speed after 2 seconds, right? The vertical component of speed does not change. Sorry, the horizontal component does not change, right? That's going to be 20 cos 30 throughout, whatever time it is, yeah? So now it's going to be 10 root 3, yeah? 20 cos 30 is 10 root 3. That's the horizontal component of the speed after 2 seconds. The vertical component of the speed, we use this formula here, right? V equals u sine theta minus 9.8t. It's just V equals u plus at from this formula here. We want to figure out the speed after 2 seconds. So we're just plugging in everything we know into here, right? So I'm going to do it here. So this one, what do we know? We know that u, we're just using to that. U is going to be u sine theta, right? T is going to be 2, right? And A is going to be minus 9.8 because it's acceleration due to gravity, right? And obviously u is 20 and theta is 30. So I can actually change that to 20 sine 30. Yeah? 20 sine 30. So all I'm doing is just using I'm just using this formula and plug it into here. So that will give us the vertical component of the velocity. And that will be minus 9.6. So we've got the two components of velocity. Horizontally, it's 10 root 3. Vertically, it's minus 9.6. So basically what we're saying here, you can kind of think of it as a vector. V is going to equal 10 root 3 I going horizontally plus minus 9.6 J. So if I want the velocity, right, I need to get the magnitude of this, which is what we've done here, right? And that gives us 19.8 meters per second. And then now the angle that it's projected at, well, 10 root 3 across minus 9.6 down, it's just going to be SOHCAHTOA, right? Because this one here is going to be tan theta is going to equal the opposite. I'm just going to get rid of the negative because I'm just interested in angle 9.6 over 10 root 3. And that gives us that one there. And that gives us 29 degrees. Does that make more sense now? I hope that hopefully that makes a bit more sense, right? And I think three significant figures is what you would leave it to. Yeah. If it doesn't specify. So done that. That's part A. Hopefully that makes more sense. Let me know if it's still a bit confusing, but hopefully that makes a bit more sense, right? Now, part B says, where did you get the Suvat equation from? You Y is V equal U sin theta minus sub 8t. That's this. You use Suvat formulas for the vertical component of your speed when you're dealing with projectiles. So that V equals U sin theta minus sub 8t, and anyone else that's asking, that's just Suvat because the vertical component of speed is going up or down, right? So you just use Suvat, yeah. So hopefully that makes a bit more sense. So now part B, it says find the angle, size of angle theta, and the value of u. So what we're going to do, I think I've actually got it summarized underneath, to be fair. Yeah, I've got this here. So with this one, okay. Now we need to figure out the size of angle u. So basically, the fact that they're asking us for the variables, theta and u, that tells me it's a simultaneous equation, right? So now, what we're going to do is try and create two equations. Now, remember, the particles are going to collide. So I'm just going to say it. This is going to be the particle P. It's going to collide here, right? Thank you very much, NS Dylan. I really appreciate it. Thank you for the £2, right? And then now I'm going to say that this is going to be the particle Q, right? And they collide at this point. And do we agree, guys? At the point of collision, right? Now, remember, this is going to travel a certain distance horizontally, right? Let me just draw a red line through at this here. And the particle Q is going to travel a distance horizontally as well, right? I'm going to call this x1. I'm going to call this x2, right? Now, do we agree that the horizontal distances that they both travel, right? They're going to be equal to 50, yeah? So we're going to say then that x1 plus x is equal to 50. Two are representing the horizontal distances that particle P and Q both travel. I remember this is after 2 seconds, by the way. They collide after 2 seconds. So what we need to do is figure out equations or expressions for the distance traveled by both particles, x1 and x2, and then we'll make it equal to 50 when we add them. Yeah? So now, how do we do this? Now let's get our table here. Remember, this table tells you what you need to know. Now, in terms of distances, guys, right? In terms of distances, hold on. I'm gonna paste this here. Yeah. So for example, x1 then for the particle P. Well, we know that horizontally the speed is u cos theta and the time is t, right? So the distance is just speed times the time. So if I use that there, then x1 based on that for particle P, right, is going to be, I'm just going to call it equal to distance, is going to be 20. That is the uh, speed, initially 20, and it's going to be cos 30. Cos 30, and we're going to times that by the time, right? And this will give me an expression for the distance that the particle P travels, right? The yellow distance. So I'm going to say then from there that, well, that's just the same as 40 cos 30 to be fair. So I'm going to say that x1 is 40 cos 30. So I'm going to put this here, 40 cos 30, like that, plus x2 is equal to 50. Does that make sense so far? Yeah? Dan, let's get a move on. It's getting late. Sorry, Harry. Sorry, Harry. I'm trying. I'm trying. Yeah? So now what we want to do now is just figure out the same thing for the u, right? Now u, remember, is x2. The distance traveled here for u, let me just do it I'll do it here to be fair. Remember, the distance is going to be u cos theta, right? Times the t. That's the general distance, right? Now, we know that it happens after 2 seconds. So we're going to say that x2 then, based on that, is just going to be u cos theta times by 2. So therefore, we could say that x2 is 2u cos theta, like that. Meaning that x2 is 2u cos theta. So we can update this equation. Let me move this table to the right, to be fair. I say to be fair a lot, sorry. So let me move this here. Whoops, hold on. Move this here. Okay. So that means then that the equation for x1 and x2 is going to be 40 cos 30 plus x2, which is what is x2? We did it here. 2u cos theta. 2u cos theta is equal to 50. And that is one simultaneous equation in terms of u and theta, right? So what I'm going to tally this up a bit, because 40 cos 30, I can put it in my calculator. 40 cos 30 is equal to 20 root 3. So 20 root 3 plus 2u cos theta is going to equal 50. Does that make sense, guys? We happy with that? Cool. All right, cool. So I think that's okay. Let me just make sure. Does the sound still working? Let me just check something. Okay, yeah, that's good. Yeah. So now what we can do is we figured out an equation in terms of theta and u, right? And we dealt with horizontal distances. Now what we're going to do is we're going to look vertically. Now if I look at the picture, the height that they meet at the point of collision is going to be the same, right? So what we want to do is basically create two equations for the height that it arrives at after 2 seconds and then equate them. And that will give us another equation, right? So we've done this. I'm going to just label this horizontal here. So I'm going to say horizontal here. This is what we did horizontally. Horizontally. Now we're going to do it vertically. So I'm going to do vertical like this. And then now, what do we need to do? We need to figure out equations for the height. So for particle P anyway, for particle P, what will the height be after 2 seconds, right? Well, for particle P, remember, now we're going to have to use the vertical formulas now. Remember, S is equal to ut plus a half at squared. Let me just check the chat. Okay, cool. So for particle P, what do we know, right? U is going to be 20 sine 30. That's going to be the vertical component of the speed, right? Because remember, it was 20. So vertical component of speed is 20 sine 30. That's uy. The time, right, is 2. The acceleration is minus 9.8. Yeah? And we're looking for S. We're looking for S. Right? What is the height after 2 seconds? So we can just plug in everything and see what we get into what formula can we use. S equals ut plus a half at squared. So plugging that in, that's going to be S is going to equal 20 sine 30, like that. Let me just get the chart out, by the way. Okay. So 20 sine 30, right? Ut, T is 2, and then plus a half A, which is minus 9.8, and then 2 squared, like that. And to be fair, that is all good. I can just put that straight into my calculator. There's no variable set, so that's fine. So I'm gonna put that all in and see what I get. So 20 sine 30, 20 sine 30 times by 2 plus a half minus 9.8 minus 9.8 2 squared, like that. That's going to give me 2 over 5. So the distance traveled by particle P is 2 over 5, right? So this distance is 2 over 5. And then what I want to do is just do the exact same thing for u now, right? And then now I can just equate that 2 over 5, and then I get another equation in terms of u and theta. So I'm going to say for particle Q, what do we know? Well, the vertical component of the speed, remember, is going to be u sine theta, right? So I'm going to just say uy is going to equal u sine theta. T is 2. What do I know? A is minus 9.8, and G and S is what we're looking for, right? So what we can say then is that S is going to equal u sine theta times by 2 ut plus a half and then minus 9.8 2 squared, like that. So now I can just tally that up. That means that S is going to be 2u sine theta here. Then now I can punch that all into my calculator. So that's going to be 1/2 times by minus 9.8, like that. And then 2 squared is going to give me, whoops, that's going to give me minus 98 over 5, or minus 9.6. So now we've got two expressions for the same height. Remember, look at the picture. We know that they collide at the same height, right? We know from the first particle P that height is 2/5. And from the second particle Q, it's this expression here. So because these two are the same, right? S is equal to 2/5 and S is equal to that there. We can now say that 2u sine theta minus 19.6 is equal to 2/5. And then what I can do here is just figure out an expression for 2u sine theta or u sine theta. Yeah? So now, what I'm going to do is going to say that u sine theta, let me just add on the 19.6. So 2u sine theta, that's going to be 19.6, or all right, 2/5 plus 19.6. That's going to be 20. So that's going to be 2 sine theta is equal to 20. That means that u sine theta is going to be 10, right? U sine theta is going to be 10. So now remember, we're dealing with a simultaneous equation. We know u sine theta is 10. From the original equation, remember, the equation where we said that the x1, x2 is equal to 50. We get this right here. Remember, we're trying to figure out what u and theta is. So we could just solve this simultaneously now. Because now, if I put this here now, remember, this was equation 1. So we got these two equations, right? Now, from here, what I can do is I can rearrange to make u the subject, right? So I can say u is going to equal 10 over sine theta. And if u is 10 over sine theta, I can punch that into here. I can punch that into there. And that way I'm going to get 20 root 3 plus 2 over 10 over sine theta multiplied by cosine theta is going to equal 50. Yeah? So, sorry, man. Sorry. Okay. Okay, cool. So now, sorry, let me see. Long ask question. Sorry, guys. But yeah, we've all just do that long as possible. I'm trying my best, guys. Apologies. But yeah, I'm nearly done anyway. So now, we can say that we've got 20 root 3 plus 20. That's 2 times 20. That's cos over sine. Like that is equal to 50. Like that. So now, what I can do is say that I can move that over. So I'm gonna have cos theta over sine theta, like that. That's going to equal 50 minus 20 root 3, like that. And then I'm going to divide by 20, like that. And obviously, cos over sine is cot, isn't it? So if that's cot, like that, 50 minus 20 root 3 over 20. Remember, you can't plug in cot, you can't take the cot inverse, right? So, don't apologize, man. Take your time. Yeah. Cool. I appreciate it. So now tan theta, remember, because cot is 1 over tan, right? So if I take the reciprocal of both sides, I'm gonna get tan theta is 20 over 50 minus 20 root 3. So now I can figure out what theta is. So I'm gonna do the tan inverse now of that. 20 over 50 minus 20 root 3. We're nearly done with this question anyway. So putting this in, that's gonna give us 52.47. And I'll just do it to free certificate against 52.5. Like that. So that's theta. Now we can figure out what u is, and then we're done, right? Because remember, u is 10 over sine theta. So I'm going to grab that there. U equals 10 over sine theta. So I'm going to grab that there. And then that means then that theta then, or u, sorry, is going to be u equals 10 over sine of that angle. But I'm not going to use that one because I've rounded it. I'm going to use this one, 52.477, blah, blah, blah. So that will give me u is equal to 10 over the sine of answer. And that is equal to 12.6. And these are the values that I got before, to be fair. So that's correct. So therefore, we've got theta, we've got u, and that's 6 marks. Yeah? Cool. 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 Okay. Okay. Fair enough. Fair enough. Cool. So we've done that. Where is it? U there. So we've done that. So state one limitation of the model. After other than errors that could affect the accuracy of your answer. So again, it's super easy. You just negate what they've told you. They told you, where is it? These must have said something about, yeah, the balls are modeled as particles, right? So that is going to be a limitation, right? Originally, or in reality, the balls aren't modeled as particles. They're going to have dimensions. There's going to be wind speed. They didn't say anything about air resistance and so on and so forth, right? So you can just say anything like that. Yeah. So now, can you do a recap? Yeah, I'll just do a recap on part B. So basically, where's part B? Yeah, part B, we need to find the right angle of theta in U. So remember, what we said then is because we've got two particles colliding, right? What that means is that the distances they both travel, because remember the whole distance is 50, it means that x1 plus x2 is 50, right? So we need to figure out what x1 is, what x2 is. Remember, x1 is 40 cos 30 times, no, it's 20 cos 30 times the time. This is x1 right here. This distance, the speed, which is 20 cos 30, the horizontal component of the speed times the time. Remember, it's after 2 seconds. That's 40 cos 30. That's x1, right? Yeah, use a more accurate value of g as well. Yeah. So now, x1 is 40 cos 30, right there. That's 40 cos 30. Now we need to figure out what x2 is. What distance has that particle q traveled after 2 seconds? We've done that here, right? Where is it? I think I did it up here, to be fair. Yeah, particle q. The initial speed horizontally is u cos theta. That's the speed. The time is 2. So u cos theta times by 2 is 2u cos theta. And that means we get these two. 40 cos 30 plus 2u cos 30. These are x1. That's plus x2. Like that. That's equal to 50. So we get that equation there. So we take equation. And then obviously vertically, we need to figure out what the height is. Because remember, at a point of collision, the heights are obviously going to be the same. Right? So now, vertically, uy is equal to 20 sine 30. For P anyway, T is 2, A equals minus 9.8, and S is what we're looking for. Let me write that as S, just so it's clear, like that. S is like that. And then obviously, we're going to use S equals UT plus a half AT squared to figure out what the height is after 2 seconds for the particle P. And when I plug in everything into there, we get this here. Plugging that in, we get S is equal to 2 over 5. So we know what the height is. We're going to do the same thing for the particle Q. Remember, the Q initial vertical component was U sine theta, obviously. So we're going to plug in that into here, and then we get this equation. So these two are the same. We can equate them. So we get this here, and then we can get this for U sine theta is equal to 10, 10 is equal to, u is equal to 10 over sine theta, and then we're going to plug this into the original equation. Remember, this was x1 plus x2 is equal to 50, and then we just solve simultaneously. So I hope that's a bit of a summary, and then you guys will be able to watch it back. Yeah? Yeah. So now we've done that, go to moments now. So I think it's probably going to be my last one. Yeah? Because it's just overrun so much. Yeah? So we're going to do moments. Are you guys happy for me to do moments? Happy with that? Let me just show you the question. It's two parts to it. You happy to do moments just before we finish? Just check. But yeah, what do you guys think about moments? Put a 0 if you don't know. Find moments confusing, or put a 10 if this is very easy, very straightforward. Yeah? And I hope that summary made sense, by the way. And I appreciate it, Officer Cucumber. Okay. So, so we've got moments now. So I'm just gonna just check to see that we're all good to continue. This here. Okay. So now let's finish off with this and see. Let me just see the chat. Okay, cool. So we're all good. We're all good. All right. So let's have a look. It says a plank rests in equilibrium against a fixed horizontal pole. The plank is modeled as a uniform rod AB and the pole as a smooth horizontal peg perpendicular to the vertical plane containing AB. The rod has length 3A and weight W and rests on the peg at C, where AC, is 2A. The end A of the rod rests on rough horizontal ground, and AB makes an angle alpha with the ground as shown in figure 2. Part A says we need to show that the normal reaction on the rod at A is a quarter 4 minus 3 cos squared alpha W for 6 marks. Now I've just got this summarized here. I've got the diagram here summarized, right? Now, firstly, when you're dealing with a moments question, right? We need to do a force diagram, right? Now, what do we know? Firstly, they told us that AB has length 3A and the weight is W. And this is a uniform rod, isn't it? So because it's uniform, where does it say it's uniform? Yeah, uniform rod AB, and the weight is W. So therefore the weight is going to act down the center. So I'm going to just put this here. Just going to put a W here, like that. Like that. And then now, what else do we know? Well, there's a particle at C, right? What's it say? Oh, it's a peg C, right? It's just a peg, but there's a point of contact, right? So there's going to be a reaction force there as well, and that's going to be perpendicular to the plane. So I'm going to call this RC, like that. And as well as that, they also told us that the ground is rough. There's rough horizontal ground. So there's a couple of things happening at the point A. Yeah. So at the point A, obviously there's going to be a reaction force going upwards, RA, and the floor is rough. Now the friction is always going to act towards the right with these types of questions. Yeah. So we get this far force diagram. Are we happy with this? Yeah. Cool. Cool. Good stuff. Good stuff. Then what's your dream car? Probably a range or a G wagon. But anyways, cool. So this is our diagram here. Now they've asked us to show that the normal reaction at A is a quarter, whatever that is, right? That expression, that trigonometric expression. So they ask us for the reaction at A. So for me, what I would need to do is, well, firstly, I would think I should resolve to get an equation in terms of A, right? In terms of RA. So what I'm going to do is I'm going to get the components, because remember, this is acting at an angle. It's perpendicular, sorry. It's acting perpendicular to the plane. So what I can do is resolve this here, like that. And I'm going to call this alpha. This angle is always alpha. Now, if I just zoom in a bit so it's clear to see, that means that this component right here is going to be the adjacent. It's going to be RC cosine alpha, like that. And then this one here, going towards the left now, this is going to be RC, and then it's going to be sine alpha, like that. Remember, opposite is sine, adjacent is cosine. Now, remember, we're looking for RA. So we're going to resolve vertically, right? So I'm going to do this here. If I resolve vertically, then that means that well, I always do, I'm going to highlight all of the force acting vertically. Got that one there. I've got this component there, and I've also got this weight W there. So that means that, well, resolving vertically, there are two going up, RA plus RC cos alpha, like that. Those are the two going up, and then the weight is going down. So I get this equation here. Does that make sense? Yeah? No, the peg doesn't have a weight. The peg doesn't have a weight. Yeah? Okay. Why would C have a reaction? Because basically, this peg, there's a point of contact here. The peg is C, and it's in contact with this rod AB. So there's going to be a reaction. Yeah. So someone donate for Dad's G wagon. Okay. So yeah. So yeah, the peg doesn't have a weight. Yeah. Anyways, now this is an equation in terms of RA. Are we happy with this equation, guys? Does that make sense? Are we happy with that? Yeah, we've got this equation in terms of RA. Now, what we want to do is, if I look at this equation, right? Because I'm looking for RA, I'm going to just rearrange. RA is going to equal W minus RC cos alpha, right? Now, obviously, we need the reaction at A, and we know that it's in terms of W. So that tells me that I need to figure out what RC is. Because if I figure out what RC is, right, then we can put that into this formula, right? So that tells me that we need to figure out what RC is. So how do we do this? Now, this is a moments question. It's always the same type of setup, right? We need an equation in terms of RC here. Now, how do we get that? What you want to do is you want to take moments, right? And you want to take moments about the point which has the most forces acting on it. And it's always A, right? If you always see a point of contact, you've got a reaction and a friction, always take moments about that point. So I'm going to take moments about A. If I take moments about A, let me just copy this again. I'm just going to get this diagram here. I'm going to copy everything just so it's super clear. Yeah. And then what I'm going to do, because I'm taking moments, I'm going to remove these components just temporarily, just to see what's going on. Thank you very much, NS Dillon, for the £2 and SVR better than G-Wagon. I can't complain. Thank you for that. I appreciate it. So we've got that here. Let me just make this a bit. Let me just make this straight, just like that, just so it looks a bit clear. Okay. So this is going to be our force RC, right? Now we want to take moments. Now, remember, when you take moments about a point, right, the forces acted at that point are not affected. So I'm going to take moments about 2 points here. Two forces, sorry. It's going to be the RC, like that, and the W, like that. I'll put it in green. Yeah? The forces RA and F are not going to be considered because we're taking moments about that point. Yeah? So, Dan, you're so clutch staying up past your bedtime to teach us mechanics. Bro, my bedtime, I'm getting older. I go to bed at 10 o'clock. So, just not yet, but I'll be going to bed soon. But anyways, we're taking moments about A. And now, remember the moment, guys. The moment, just by definition of it, just so it's super clear, right? If I've got like a particle like this, whoops, if I've got something like this here, draw a line like this, and let's say this is the point A, and then let's say this force is, I don't know, let's say this force is, I don't know, mg, for example, yeah? And then this distance here is, I don't know, 5, yeah? The force is going in that direction. This distance of 5 meters is perpendicular to the point A. So the moment, right? The moment is going to be equal to the force mg times by the distance 5. So it's going to be 5 mg in this example. Does that make sense? And obviously, it's swinging that way, and that is going to be anti-clockwise, isn't it? So this is an anti-clockwise moment. So if I use that same logic here, right? Well, what would the moment for RC be? Well, the moment, remember, also as well, if it's an equilibrium, the anti-clockwise is always going to have to equal the clockwise moments. If I look at RC is going to be the force, obviously, and I'm going to multiply by that distance, which is 2a. That distance from C to A is 2a, right there, right? So it's going to be RC times 2a. And again, this is anti-clockwise, isn't it? Like that, ACW, like that. So I can do that. That is definitely the left-hand side, yeah? Now, I'm going to make this equal to the clockwise moment. Now, the other moment we're dealing with is this weight W. So what I always do with these ones, I'm going to draw a right angle triangle again, just to really indicate what's going on here. Whoops. Like that. So now, this is going to be alpha. This is the point A. Now, what do we know? W acts down the center. The entire, let me move out that pink because it's a bit distracted. The entire distance of the rod A to B is 3a, as we can see here. 3a right here. So halfway is going to be 1.5a. So therefore, remember the force is weight is acting down that way. And I always just extend it so it's like this. So these are just the same thing, like that. I need to figure out what this distance is. This one right here. Because that is the perpendicular distance away from this force, isn't it? Right? I need to figure out what that distance is. Now, this is just going to be 1.5a cos alpha, isn't it? Yeah? Because of the fact that it's a hypotenuse, this is the adjacent. 1.5a cos alpha. That is the distance. So the moment, and again, this is going clockwise. This is going clockwise. Let me put this as capital A. Capital A. The moment is going to be, and we're at clockwise here. That's going clockwise. It's going to be the force, which is W, times by the perpendicular distance, which you can see quite clearly is 1.5a cos alpha. So I can put this there. So I get this equation. And this is an equation in terms of RC, right? Now, this is helpful because remember, we're looking for RA, which is W minus RC cos alpha. I now have an equation in terms of RC that I can find, right? So what we want to do is say, well, fine. Tidying that up, that's going to be RC is going to equal W times 1.5A cos alpha divided by 2A. Now, that means that RC is going to equal 1.5 divided by 2 is 0.75, which is the same as 3/4 to be fair. So I'll just highlight that so it's super clear. 1.5 divided by 2 is 0.75, so 3/4 can go there. The A's are going to cancel, and then I've got W cos alpha. So now I've got RC, right? RC is equal to 3/4 W cos alpha. Remember what we're looking for though? We're looking for RA, right? So what I'm going to do is I'm going to copy this and I'm going to put this here like that. And then now, because I know what RC is W cos alpha. Let me just get rid of the highlight so it's not distracting. So I'm gonna put this in. That means that RA is gonna equal W minus 3/4 W cos alpha times another cos alpha. And remember, let's get the show that up. Remember to show that question. We're trying to show that the reaction at A, RA, is equal to that there. We've got this expression. So what can I do from here? What I can do is say, okay, well, fine. I'm gonna get RA, and then tidying that up is gonna be W minus 3/4 W cos squared alpha. Now, what can I take out? I can take out a quarter and a W. If I take out a quarter and a W like that, then well, how can I get back to that? I need a 4 to get the W, and I'm gonna take it's going to be 3 cos squared alpha. So we get what they want on the inside, and then obviously they just put the W on the other side. So therefore we can say that RA is equal to 1/4 4 minus 3 cos squared alpha times by W. And that's it. Does that make sense? We happy with that? Just before I continue. So I just zoom out to see all of the working. So again, at moments it's the same thing each time, right? Cool. Oops, I forgot to get rid of this. That should be on the... I'm on the wrong thing. Okay, no, I'm not. This is just the answer here anyway. For this, the mark scheme. But yeah, got that. That's fine. Anyways, let me move that out the way. So now we've done part A. Let's do part B. All right. So part B, let me put this in. How do you figure out if it's anti-clockwise or clockwise? So you just figure out where it's swinging. So for example, this RC force is swinging towards A, right? Because we're taking moments about A. That is going in a anti-clockwise direction, isn't it? And then this one is going towards A. That's clockwise. So just think of a clock. Which way does the clock turn, right? Now, doing that, let's do part B. It says, given that the rod is in limiting equilibrium and that cos alpha is 2/3, right? Find the coefficient of friction between the rod and the ground. So again, how do we do this one? So we need to find the coefficient of friction, right? We know that mu is equal to, oh, let me write this actually, because what we do know is that F is equal to mu R. And if F is equal to mu R, that means that mu is equal to F divided by R. So what that tells me is that I need to figure out what the friction is and what the reaction force is, and then divide them, right? So let me just get this here. What do I know? I'm just gonna get these here again. Let me just get my forces. It's gonna be RA, like that. That's gonna be friction. That's gonna be friction. The weight was W, and we had the reaction RC, right? So, well, what do we know? Well, firstly, we know what RA is, right? So let me just get these components because we're going to need to resolve, to be fair. So I'm going to get these components like that now. And let me rub out this RC. Let me just rub this out here. So I'm going to get this here. And then I'm going to have, that's going to be alpha. And then this is going to be RC cos alpha, which we know, but I'm just going to put it in like that. And then this is going to be RC sine alpha, isn't it? Sine alpha, like that. Let me just check the chat. Just to make sure we're all okay. Wait a minute. Okay. What's going on here? What's going on? I'm just trying to get the chat up. Okay. Okay, brilliant. So now, yeah. So what we can do is, by the way, they told us that cos alpha is 2/3, by the way. So let me get that. Cos alpha is equal to 2/3. So let me just see what we've got here. Now, remember, we know what RA is equal to, by the way, because we worked that out. So let me get that first, right? Because remember, it's mu equals F over R. Now, remember, the reaction is RA, technically, isn't it? So I'm going to work out what RA is. Now, obviously, we actually did that, to be fair. It's that. But since I know what cos alpha is now, which is 2/3, I can actually make this simpler, right? So I'm going to put this here. Put that there. So we know what RA is. And we know that cos alpha is 2/3. So I can actually figure out what RA is in terms of W anyway. RA is going to equal 1/4 4 minus 3, and then cos squared alpha. That's going to be 2/3 squared, isn't it? Because cos alpha is 2/3. So I can put it there, and then W. And then what I can do is just punch this all into my calculator to figure out what the coefficient is here. So I'll do that and see what I get. It's going to be 1/4. It's going to be 4, 3, 2/3, like that, all squared, and that will give me 2/3. So RA is 2/3 W. Does that make sense, guys? Are we happy with that? Just before I continue, just to make sure all okay. Yeah. All right. So we've got RA in terms of W now. Now remember, we need friction too, so we need to resolve horizontally. And yeah, good stuff. Cool. So now, if I resolve horizontally to get friction, well, what can we see here from the diagram? Well, the friction is acting horizontally, obviously, and so is this component, right? RC sine alpha is just acting in the other way. So therefore, we could say, if I resolve horizontally there, we could say that the friction must equal the RC sine alpha, right? Now remember, we know what RC is, by the way. RC was 3/4 W cos alpha. So I'm going to grab this here. So we're nearly done with this question. And we're going to call it a day. Paste here. That's RC. Like that. So I'm going to put this there actually because I'm using it here. So that means then that F so far, by the way, is just going to equal, F is going to equal RC, which is 3/4 W cos alpha. And then we're going to times by sine alpha. Now, let me rub this out. We know what cos alpha is. Cos alpha is 2/3, right? So we're going to have F is equal to 3/4 W, and then cos alpha is 2/3, like that. So what that tells me is that I just need to figure out what sine alpha is, right? And I'm done. Now, if cos alpha is 2/3, which it is, right? I could figure out the trigonometric expression for sine alpha. I'm going to write alpha here. I know that cos alpha is 2/3. So that means that, well, remember, this is the adjacent. This is the hypotenuse. So the adjacent is going to be 2 here. The hypotenuse is going to be 3 here. I could use Pythagoras to figure out what this side is. That's just going to be the square root of 3 squared take away 2 squared. Hold on. 3 squared take away 2 squared. That's going to give me root 5. So therefore, I'm going to have root 5 here. Like that. So now, if that's the case, then sine alpha, which we know is the opposite over the hypotenuse, is going to be the opposite side, root 5, divided by hypotenuse, which is 3. So therefore, sine alpha is equal to, whoops, needs to go, what's up in there? Okay. So that means that sine alpha then equals root 5/3. So if sine alpha is equal to root 5/3, then I can plug that in here. So I'm going to get F is going to equal 3/4 W times by 2/3, and then times by sine alpha, which we now know is root 5/3. Does that make sense? Yeah? Okay. So you're welcome, Crimson. You're welcome, Crimson. We're gonna round up, yeah? So now tidying this up, F is gonna equal let me just put this in here. I can just, to be fair, I can put this in a calculator. That will cancel with that, like that. And that's gonna be, you know what? I can cancel it, but let me just put it in a calculator just so it's just super clear anyway. So it's gonna be 3/4 times by 2/3 times by root 5/3. That's gonna just cancel everything. So I would recommend doing it this because you've got a calculator anyway. That gives me root 5/6. So that tells me that F is equal to root 5/6 W. Now remember what they asked us for, the coefficient of friction, which we know is mu, which is F divided by RA. So we're gonna say that mu, which we know is equal to F divided by RA, is gonna equal root 5/6 W divided by RA, which we said was what was RA again? Where was RA? That one there. RA was right here. 2/3 W. So we've got 2/3 W here. Now, that's going to cancel with that. The answer is just going to be root 5/6 over 2/3. So put that in and see what we get. So it's going to be root 5/6 and then 2/3. And that gives me root 5/4. So therefore, mu is equal to root 5/4. And that's it. That's it. We're done. We're done. I had another question, but I don't have time to finish it. But what I can do is the link to these notes, right? I'm going to send to you guys, right? But yeah, this is the other question, but I don't have time to do, unfortunately, because I've overrun by quite a bit. But I'm hoping that this has been helpful. And does this question make sense? We happy with this? Yeah. Make sure we're all good. Just see the chat. Okay. Okay. Cool. Let me just see. Sound working? Yeah. Okay, cool. Sure, all good. Okay. So let me just see. Jalen says that which your thoughts follow for these questions. Yeah. So what I would say, KA, is what is it? Yeah. What you should do is always resolve, always draw your force diagram, and you always take your moments. Yeah. Let me just see. Thank you so much. Please do one more, just one more. Thanks, Dan. Should I do the last one? How much? How many people are there? 426. Should I do the last one? Let's see. Okay. I think I'll do. Okay. All right. All right. All right. Okay. I'll do it. I'll do it. I'll do it quick. I'll do it quick. I'll do it quick. I'll do it quick. What's the time? Okay, I'll do it. I'll do it. I won't rush it, but I'll do it quick. I'll do it quick because you guys are asking. But yeah, just as long as I'm not boring you guys. But yeah, we'll do this and keep the change. I appreciate it, Will. I appreciate it. I appreciate it. All right, cool. All right, cool. I'm gonna do this one. I'm gonna do this one for you guys. So, where is it? Let's read it. Let's read it. Let's read it. Let's read it. A particle P of mass 4 kilograms is at rest at the point A on a horizontal plane, right? At time t equals 0, forces F1 4i minus j newtons and F2 lambda and mu j newtons, where lambda mu are constants, are applied to P. Given that P moves in the direction of the vector 3i plus j, show that lambda minus 3 mu plus 7 is equal to 0, right? Now this one, I've got it summarized here. Now what you want to do with this one, they've told you that P moves in the direction of the vector 3i plus j. If you've got a particle when the forces have been applied, that just means that your resultant force is moving in this direction. Because remember, F1 and F2 are going to sum to make the resultant force. And what they're saying is that the resultant force, which I call F, right, which is F1 plus F2, is acting in this direction of 3i plus j. But remember, if it's in the direction, it could be any multiple. So I can actually write this as 3ki plus kj. Yeah? So what we want to do is, let me just write 3ki plus kj. What we want to do is we want to figure out the expression for the resultant force, and we're going to just add F1 and F2 together. So that will give me 4i minus j plus F2, which is going to be lambda I plus mu j, right? And we know that this is going to be acting in this direction. So I'm going to call this 3ki plus kj. Does that make sense, by the way, this direction stuff that I'm doing here? Does that make sense? You can never bore me then. I appreciate it. Okay. Cool, 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 cool. Who's that? Who's that trolling? Oh, you guys are funny. Anyways, cool. So if you've done that, and yeah, hopefully that K stuff makes sense, right? It's just basically because it's in a direction, it's parallel, right? Moving in a direction, it could be any multiple. So that's why I put the K there. So now, if I tidy this up, this is gonna be, if I just bring the I's together, I can write this as 4 plus lambda, sorry, I, 4 plus lambda I, like that. If I just group these, that's an I there, that's an I there. I'm just grouping the 4 and the lambda there, right? To give me that, that's fine. And then if I do it for the J's now, put it in a bracket. Well, I forgot the J here, didn't I? Sorry, I forgot to put a J here. Sorry. So now, if I compute the J's or group the J's, then I've got a mu here. I'll just put it here. And then I've got this -1. That's a -1. So I get mu -1. So I get that there, right? And then this is equal to 3ki plus kj. Cool. No, you don't find acceleration and then integrate for this one because it didn't really say anything about what have they given us? They haven't given us an expression for the velocity or anything like that. Yeah. So when you see like on variable acceleration when they say v is equal to something like that, or r is equal to this, or s is equal to that, then you have to use the differentiation and integration. So yeah. Now, what we can say then is that because this force here is acting in this direction, right? These vectors are the same. So what that means is that I can equate these components. That is going to equal that, and then that one is going to equal that one. So I get that there. So what I'm going to say then is that the 4 plus lambda is going to equal 3k. That's one equation. And the mu minus 1 is going to equal k. That's another equation. Does that make sense, guys? Before we continue? Yeah. Arjun, you can definitely use columns. I'm just using IJ because that's what the question has. That's the only reason why, but you can definitely use columns for sure. Yeah. So we've got this now. Now remember, they've asked us to show that we get this head. We've got two simultaneous equations, right? I'm going to call this equation 1. I'm going to call this equation 2. Now, what you can do with this one is you can just literally divide them. Equation 1 divided by equation 2. That will give me 4 plus lambda over mu minus 1 is going to give me 3k over k. and we can see quite clearly that the k's are going to cancel, similar to that other one we did with the pulleys, right? So that will give me 4 plus lambda, sorry, over mu minus 1 is going to give me 3 over 1. And then now we can just cross multiply. So we're going to get 4 plus lambda. I'm going to times that by 1, obviously. And it's going to give me 3 bracket mu minus 1. And then now this is easy. This is 4 plus lambda. This is 3 mu minus 3. And remember what they want us to show? Lambda minus 3 mu plus 7 is equal to 0. So I'm going to move everything from right to left. So that will give me lambda. If I move that 3u, it's going to be minus 3 mu. 3 mu, sorry. And then if I move that minus 3, it's going to be plus 7 is equal to 0. And that's exactly what they wanted. Let me just see. Yeah, perfect. We got it. Does that make sense? Yeah? Cool. 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 So we've done that. Now let's go to part B. Last question. We're going to finish at 10 o'clock. That's crazy. Anyways, at time t equals 4 seconds, right? P passes through the point B. Given that lambda is 2, find the length of A to B. Now, remember, what have we figured out, by the way, in part A? We know that we get this equation, right? Let me just copy it. Copy this one right here. And then paste in this one right here. We know that lambda is 2. So if I plug in lambda equals 2 into this, then that's going to be 2 minus 3 mu plus 7 is equal to 0. And that would mean that 9 minus 3 mu is equal to 0. So therefore, 9 is equal to 3 mu. And that would mean that mu is equal to 3. So we now know what lambda is and what mu is, right? Lambda is 2, mu is 3. Now remember, they're asking us for the length, right? At time t equals 4 seconds, P passes through B. So now we've got to use suvat, right? But firstly, remember, we had a particle P of mass 4 kilograms, right? And we knew the resultant force, right? What we can do is use F equals ma to figure out an expression for acceleration. So what I'm going to do here is I'm just going to write we need A, right? A. And I'm going to just say F equals to ma. Now remember the resultant force, by the way, the resultant force was this expression here, isn't it, for the vector? Now I know what lambda and mu are. I could figure out what the vector is for the resultant force. So if I plug in what I know, remember I know that lambda right here, lambda is 2, mu is 3. So if I plug that in, that means F is going to equal 4 plus 2 is 6. That's going to be 6i plus 3 minus 1 is going to be 2j. That is the force. Now remember, F is equal to ma. That means I'm going to have 6i plus 2j is equal to the mass. Remember, the mass of the object was 4 kilograms. 4 kilograms. Like that. So I'm going to have 4a here. And that will allow me to figure out the vector, right? For the acceleration. So that would mean that I'm going to have a is going to equal 6 divided by 4i plus 2 divided by 4j. So therefore, that's going to be 3 over 2. I'll write as decimals, to be fair. I think it's easier to write as decimals here. Be 1.5, 3 over 2, 1.5i plus 0.5j. That is the expression for the acceleration, right? Now, what did they ask us for? They asked us for the length of AB. Remember, A is where it was started at. Let's just see. Particle is at the point A, right? So basically, let me just get a diagram just to visualize. We're at the point A here. Point B is here, and this is what 4 seconds later, isn't it? T is equal to 4. And we need to figure out what this distance is, right? We know the acceleration. I'm just going to write A here. We know. I'm going to write the ones that we know in circles because they're long. A, we know. We know, what else do we know? The time, right? Yeah, the time is 4, obviously. I'm going to write T here, right? And they're asking us for the distance. And obviously, did it say anything? What did it say? It was at rest. Perfect. We know U is equal to 0. So I'm just going to write these here. I'm going to write the variables that we know, right? And we're looking for the distance, which we're going to use R, right? So now this stream is older than Duke. I wish I knew what that meant, but I'm guessing Duke is somebody old. Anyways, so we're going to use R. Remember, we're dealing with vectors. It's going to be UT plus a half AT squared in vector form, right? So R is going to equal, U is 0. Remember, it's from rest. U equals 0. So it's going to be 0 times the time, which is 4, plus 1/2 the acceleration vector is that there, 1.5i plus 0.5j, and then the time is 4. So I'm going to put 4 squared here. So therefore, I'm going to have r is equal to, and then to be fair, let me try it out one more time. There's 1.5i plus 0.5j. That's going to be 16. Yeah. So therefore, r is going to give me half times 16 is 8. So I'm going to put 8 on the outside, 1.5a plus 0.5j. So now I'm just going to expand this to give me an expression for the vector for the distance, which is going to be 8 times 1.5, 12, so 12i, and then that's going to be 4j. This is going to be our expression for our vector, right? Our displacement, I should say. It asks us for the length. So what do we need to do now? We just need to get the magnitude of this, don't we? Let me just make sure. All okay? Just making sure we're all good. Okay, cool. I'm still streaming. It's still good. Okay. Okay. All right. So now I'm just going to take the magnitude of this to figure out what the actual length is, and that's going to be 12 squared plus 4 squared. So that's going to be plugging that in. Square root of 12 squared plus 4 squared. Now that gives me 4 root 10. So that means that the distance is going to be 4 root 10. Let me just make sure I got that correct, by the way. Is that what I got before? Where's my answers? Did I get that? Let's check. Brilliant. We're done. We're done. 10 o'clock. How long has it been? 2.5 hours. Crazy. Crazy. But yeah, does that make sense? Are we happy with this? Yeah? Oh, what is wrong with you guys? You guys are crazy. But yeah, happy that guys. How many questions we got through? We got through 8 questions, 2.5 hours. Wow, that was not expected. But yeah, how are you guys feeling for tomorrow? Hoping you guys are feeling a bit more confident. Yeah? Cool. Cool. But yeah, I'll just say, let me just see. I appreciate it, guys. Appreciate it. But yeah, hopefully you found this helpful. Hopefully it wasn't too long. But yeah, just wishing you guys the best of luck. Any advice for tomorrow? Let me just go back to big cam. How do I do that? So I'm gonna do this like that, and I'm gonna go to big cam like that. Wow, I'm tired as you can see, mate. I did not look like this at the beginning of the stream. But yeah, I just want to wish you guys the best of luck. As a tip, what I would say is just go through projectiles moments. Obviously don't do too much because obviously you got to wake up early, but yeah, just make sure you know your formulas, especially for stats, and you'll be fine. But yeah, guys, it's been a pleasure. This is the last stream. It's been a long time. It's the 7th stream I've done. So I'm gonna go to bed now. I'm done with streaming. I'm done with making TikToks. I'm gonna just sleep, as you guys will do after exam tomorrow. But guys, it's been a pleasure. Thanks for supporting. Thanks for just being great. And it's time to catch up on Long Island. I've missed a couple of days, to be fair. But yeah, you guys, it's been an absolute pleasure. Best of luck for tomorrow. And yeah, let me know how your results go in results day. Do keep in touch. And yeah, let me just see. Okay, cool. How much come up in LDS? How much do you think will come up in LDS? I don't know. But probably like it's always like a couple of marks, isn't it? It's never that much. Yeah. But yeah, what I'll do, I'll try my best to do the timestamps, right? Before I sleep, because that will be my last thing to do, then I'm done. But yeah, I'm gonna miss you too, guys. I'm gonna miss you too. I'm gonna miss you too. But it's been a pleasure. Guys, best of luck. Let me know how it goes. I'm gonna end the live stream now. You guys are gonna cook that exam. Take care. Bye bye.